What is up, everybody? What is going on? I hope you all are having a great Saturday night or Sunday morning, depending on where you're at or whatever it may be. But it's an awesome Saturday night. It is almost 10 o'clock my time, almost 11 Eastern, almost 9 o'clock Mountain, and almost 8 o'clock Pacific. Very great to see all of you all in here. So thankful for all of you. Thankful to see Saved by His Grace is in here. Debbie is in here. Libby is in here. Melanie is in here. Thank you very much for all of you being in here right now. Thank you so much. Looks like One Man Show is in here. Sheila's in here. Man, we got a lot of people in here right now. This is awesome. So, very happy. Got Tammy in here, and you all are awesome. So, um, but hello to all of you. Great to see all of you. Um, but yeah, very great to see each and every one of you. You guys are all awesome. I just want to start with a few announcements. So a couple announcements. So I did put out a community post earlier this evening. Couple of community posts a little bit earlier this evening about rebranding my channel. So my channel has now been rebranded to fit more of my forward goals and future goals and fit more of my wheelhouse per se. So now you will see John Boy WX. You will see Severe Weather Lab in Education. So again, so this is a rebranding of my channel. This is a rebranding of what I love to do, and this falls more along the lines of the brand that I am pushing out and pushing forward. So again, this is a rebrand. As you can see from the graphics, you can see from some other things as well. What's going on, but to fit my expertise and to fit my love and passion for weather and how I can help, it makes sense to rebrand and to make it more just well known in that aspect. So will I also though continue to make 7 and 7 videos? Yes, I will. I will continue to make videos as well, just not as often, as I have found that live streaming is actually what I love to do. I love to live stream. I love to teach. I love to talk weather. I love to be a part with all of you. So definitely, definitely the rebrand. As I've grown my channel, and thankfully, pushing almost pushing almost 3,000 members. So 3,000 members coming up, knocking on the door. 3,000 members. So as my channel continues to grow, as I continue to grow across multiple platforms, a rebrand was in order for that. So needed to rebrand, and hopefully let me know if you guys like the new graphics, if you guys like what is what you guys see out there. So again, this is a rebrand, but this is a rebrand for the good. This is a rebrand about pushing forward the initiative of being able to teach, being able to Um, being able to just help all you guys out, being able to talk weather, learn weather. So definitely, just very thankful for all of you. Thankful that you all are here. So again, rebranding. This is the new rebrand, and this is just very thankful for all of you. Very thankful that you all are here. Very thankful for again growing. Obviously, my channel has grown because of all of you, and again, the rebrand was in order to push forward. Again, the agenda that I am pushing forward. So thankful for all of you. Thankful for that. And there is some more other cool things in the pipeline for my channel as well, and I will keep you guys informed of that as well. So a lot of great things that are going on. So just yeah, let me know if you like the graphics. I love the graphics. I think the graphics are cool. I think the new logo is pretty awesome. So definitely want to just partake in that and rebrand the channel. So that's why the rebrand happened. That's why the rebrand is transpired for. So let me jump back into chat here real quick. Looks like we got Monk in here. Great to see you, Monk. Great to see you, One Man Show. Great to see you, Melanie. Speaking of Melanie, her husband earlier, John McKinney, had a great stream earlier today for members only. So that was pretty cool to see his stream earlier today for members only. So very great stuff for that. Very proud and very happy for that. So um, thank you to my beautiful wife who is in here. Yes, we are so blessed for all of your support, and I am blessed to have my wife's support as I continue to push forward on this. So, but yeah, so very great, very awesome. Very thankful for all of you. Thankful for Papa John's, Pastor John's member stream earlier today. It was awesome watching his stream yesterday and seeing him and his sister and his brother-in-law out there. So that was pretty awesome watching them out there chasing yesterday. So pretty awesome stuff. But again, a rebrand, and very thankful for all of you. Very thankful that you guys are passionate about weather just like I am. Very thankful that you guys trust me, and that you like that, and that you like to be here. So I changed a lot of wording in my bio on YouTube, so you can read that as well. Talks about the severe weather lab here and the teaching and education part about that. So yeah. So very awesome, and just very thankful again for all of you. Very thankful for the to be able to rebrand and to be able to really dive into what I love, and to be able to push that, and to be able to get that across the whole YouTube platform, and not just across YouTube platform, but also across Twitch, across Facebook, and across Kick as well. So again, multi-streaming today, multi-streaming tonight. Very thankful for that. So blessed that you all are here. Looks like we have Omni in here. Great to see you, Omni. I don't believe I missed anybody. If I missed anybody, I apologize, but thank you all for being in here. You all are awesome. You all are amazing. Again, I've almost pushed 3,000 subscribers, and that is amazing in this short amount of time. And I am so thankful and so blessed to have each and every subscriber that I have. So, with that said, again, this is the rebranding, and there are some things in the pipeline as well, working for my channel as well, that I will let you guys know coming up in the future as well. So, very awesome, very thankful, very blessed for all of you for being in here. You guys are definitely amazing. So yes, so definitely um, very thankful. So uh, Omni says self promote. That's a new one. Yes, I am not like many streamers and many other um, people like that. Because why? Why is that? Because I am all about us promoting each other, and all of us are growing each other and growing the community. So if people want to come in here and self promote and grow their channel and grow their community as well, that's what this is all about. This is all about a community. This is all about us being one and being together. So it's not going to hurt me or affect me if somebody comes in here and self promotes. It's only going to help them get better. So, and it's only going to help me get better as well. So, self promote away. So, whatever somebody comes in wants to self promote, I'm all for, and I'm all for that. So, that's how, and that's what happens is when people don't allow self promotion on different channels, is it actually stifles growth. It stifles the community growing, and we can't allow the community to be stifled. The community has to grow, and it has to grow completely by allowing us to promote self promote on each other's channels and grow. So, and that's okay if people outgrow me. That's okay if people outgrow my channel. I'm perfectly fine if somebody does the same thing I do and they have, 10 times the amount of subscribers and 10 times the amount of followers I have. That's fine. I don't care. What I care about is us as a community growing together. So if somebody surpasses me, great. Great for them. I'm very happy for them. So again, that's why I say come in here and self promote yourself away. So it's very good. So it's very good to understand that this community, and when I say community, this weather community, even the YouTube community, this is not just about me. This community is about us and as being one. So that's why self promotion is very key, because at the end of the day, we want to grow ourselves, we want to grow our channels, and we as streamers and as YouTubers should allow other streamers and YouTubers to come in and promote themselves. And One Man Show says, I like to promote Jesus Christ, our Lord and Savior. Yes, that's I love to promote him as well. Um, so yes, definitely amen to that. One Man Show, definitely. I love promoting Jesus as well, and I love the fact that he loves promoting me as well. So very awesome. One man, excellent point out there. Just very awesome that. So, but again, you guys are awesome, and that's why my channel is different from many other channels. Again, it's about I understand the whole. I understand the community. I understand the fact that we are better as in numbers than just in one. So again, anybody who wants to come in here and promote their channel, come in here and promote your channel. That's what I actually want you to do that. So please come in here and do that. But yes, so it's just awesome stuff. So again, rebranding is very good. Rebranding again is again going to be just the way to help promote me further and help push me further and understand the channel if somebody comes across my channel and understands what the channel is about. So but again, we there are some new things coming along the way, and I will give you a little bit of updates. I won't go too deep into it, but one thing that I will be doing more is actually going live during severe weather events. So that will be again kind of like a Ryan Hall, y'all, kind of like a Max Velocity, kind of like that. So I will start to meander down that path of doing that. So again, are they are super far. Obviously, they are the top two dogs on YouTube, but again, there's always room for more. So again, that's in the works for later on. Um, but yes, that is in the works. So I will be going and doing that and popping in to help show and to keep America warned. Because at the end of the day, my goal is to provide live reports and go far beyond live reports and provide live streaming and teaching. So I have a business plan. I have things set up to where I can grow and be different from other, like a Ryan Hall, be different and be different from Max and things of that nature. But that is what the foray that I will also be doing as well, is to help keep America warm, because at the end of the day, I am on a mission to be America's weatherman, to be America's um, trusted source for weather information, and for trusted source for weather teaching, trusted source for helping the weather community grow. So that's the mission I'm on. And again, you don't know until you try. You don't know until you do it. So again, yes. So that is the goal. That is a plan that is in place. So yes, working on some things in the background here to make sure that it'd be all up and running as smoothly as possible when that comes about. So again, you guys are awesome. You guys are very awesome. Everybody in YouTube is awesome. Everybody on Kick is awesome. Everybody on Twitch and everybody on Facebook. You all are awesome. So, but again, we grow and we grow together. So, this very, 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 very awesome. So again, a lot of great stuff that's going on, a lot of great things that are happening. But again, it is all due to the God and all due to the glory of God. So, um, very, very thankful, very, very blessed. So, again, wanted to give you guys that input. Wanted to give you guys that. Um, wanted to give you guys that. Kind of the insight to what's going on. So, and I also have an email. I don't know if it is in my bio. I posted it. I don't know if it came through, but I uh, do have a public email that is either going to be posted or is posted. So if any of you all want to contact me through my email or whatever it may be, the lab is open 24/7, so you can ask anything you want to know about weather when it comes to that. So feel free to email me 24/7, any time of the day or night, and I will answer your question as soon as I can, or whatever it may be. So it doesn't have to be about weather. It can be about something you want to learn, something that a prayer request, anything. Feel free to email me. So, if that is not in my bio description on YouTube, I will put that in there after the stream. So, again, you have to grow the community and you have to be able to be accessible. So, and that's how we learn, is being accessible and having information readily available. So, again, you guys are awesome. You guys are the reason I do this. You guys are the reason that I'm I'm able to do this. Having almost 3,000 subscribers again is pretty wild. So at this stage of just starting out streaming, so very, very thankful for that. So what's on the agenda tonight? What is the topic for tonight? Well, I thought about this for a little while, and I know clouds are not very, some people, it's not the most sexiest thing in weather. It's not the most cool thing in weather. However, clouds play obviously a huge significant role in the weather. So, again, it might be a little mundane. It might not be the hot topic. It might not be the coolest topic, but there are some cool facts about clouds. There are some cool things that when you look at clouds, you can go, hey, maybe I didn't know that. So, um, yeah, and so yeah, it's just very, very awesome. So that's on the agenda for tonight is clouds. So without further ado, let's jump into clouds. But before that, as always, I have to always give glory, honor, and praise to my Lord and Savior Jesus Christ, because without Him, none of this is possible. He makes all of this possible. He has united all of us together. I'm so blessed and thankful for His love and for His mercy and for His grace. Thankful that He always promotes me and loves me exactly the way that I am, and continues to love me and always be there for me. So again, I have to um, always give glory and honor to my Lord and Savior Jesus Christ. And again, if you do not uh, know Jesus as your personal Savior, please reach out to me. Please reach out to somebody in the chat. Please, um, or please reach out again to me, or please reach out to somebody in the chat so we can point you in the right direction, and so you can start to have a relationship with Jesus. So that is the most important relationship that you will ever have. It's not the relationship with your kids. It's not the relationship with your parents. It's not the relationship with the mailman. It's not the relationship with the local groceries person. It is the relationship, your personal relationship with Jesus. That is the most important relationship that you will ever have. And because why? Because Jesus loves you exactly the way you are, and Jesus will never ever leave you. Jesus will always be there for you and help you and guide you and teach you. As long as you are willing and you are asking the right questions and you're seeking after Him and you are being obedient and you are doing the things that is asked of you to do, it is great. And that is the greatest relationship, again, that you will ever have. So, and again, the people who uh, support you through that and everything are the people that love you, are the people that care about you. So it is very awesome to have that relationship. So, but again, be bold for Jesus because He is always bold for you. So let's jump in to clouds. So we all seen clouds, or we all see clouds pretty much every day, right? So clouds, clouds, and more clouds. So they're there all the time, right? So let's look into an introduction, and we'll get a little bit scientific on it. We'll get a little bit to the meteorology side of it. Won't try to bore you too much with it. Try to keep it, pretty cool and entertaining when it comes to clouds. Hopefully, this is some stuff maybe that you uh, have not learned, or maybe you have forgotten. So maybe this could be a refresher type of course, a refresher type of session for you. So, but show of hands, how many of you have ever taken a clouds like course or learned about clouds before? So please let me know in the comments what that looks like and if you have before. So And with that, we will start and we will kick into it. So, clouds. We see clouds almost daily, yet they are complicated and varied. Says it right there, right off. And if you're wondering what I'm using, I can post it in the description. But this comes straight from NOAA, or also the National Weather Service. So again, this is the authority. This is um, them telling us about clouds, and NASA also has some really great stuff on clouds as well too. So I would highly recommend you check out NASA's got some great videos. NASA's got some great things on there as well. But again, we see clouds almost daily, yet they are complicated and varied. In fact, the simple presence of clouds tell us little about the weather without learning more details. So again, clouds are complicated and varied. So pretty cool. Thank you guys for letting me know in the chat. Looks like Libby says it's been a while, although I try to read about them when I see an article or post. Awesome, thank you. Tammy says, what? Tammy says the first storm spotter classes had a lesson on clouds. Awesome, great job there, Tammy. Awesome. Thank you so much. Thank you, Sheila, as well. Thank you, Debbie, as well. And thank you to everybody who's watching on Twitch. Thank you to everybody who's watching on Kick. And thank you to everybody who is watching here, watching on YouTube and on Facebook. And Melanie McKinney says, we used to cover clouds when I was homeschooling Freddie a long time ago. We still have the poster with cloud types illustrated that we had up when Freddie was in middle school. Awesome. Awesome. Everybody give some W's there to Melanie, because that is awesome. Homeschooling is not an easy task, but even cooler to have the poster up there with clouds and teaching Mr. Freddie McKinney about that. So very cool stuff there. So let's get some W's there for Melanie. That is pretty awesome. So very cool. Very awesome there, Melanie. Great job. Very cool to see. Very cool to hear about. So when it comes to that. So awesome. So again, yeah, I see some W's there for Melanie. Awesome. Thank you, chat, as well. So we look at clouds, but sometimes people don't even know what the clouds are. They don't know what makes up a cloud, why the cloud is there, how the cloud, how the atmosphere plays into the cloud. It's the cloud's there. We just see it, but obviously it's there for a reason. So again, this is what a cloud is, and this is why we see clouds. And again, I do not know if it's been proven true or false. Somebody let me know in the comments. But I remember quite a little while ago, I remember a cartoon called the Care Bears, and they used to float on the clouds. I don't know if that has been proven or disproven, but I don't know if you want to try that. So you might want to search up to make sure that is proven before you go try to jump like a Care Bear on a cloud. So again, just make sure that you check that out before you try to do something like that. So, but yes, so clouds are the visible aggregate of minute particles of water. So we're talking about water. So clouds are either made up of water or ice that form when water vapor condenses in the atmosphere. So how cool is that? Clouds can be made up of water or they can be made up of ice. So pretty gnarly if you ask me. So what we're looking at, what we're seeing is we are seeing condensed water or condensed ice in the atmosphere. That's what we're seeing. So to me, that is pretty awesome. So again, a lot of people don't know that. It's just there. The clouds are there. So clouds can grow very tall or appear flat as a pancake. And flat as a pancake, as we know, that is a lot of times is the anvil cloud. It has it pancakes out. So they are typically white in color, but can also be different shades of gray. And I think a lot of us have seen gray clouds a lot. It's raining, it's uh, certain type of atmospheric conditions. But a lot of times when it's raining now, a lot of times that's when we'll see gray clouds. And sometimes we can also see gray clouds, even in fair weather as well. So again, different shades of gray or brilliant yellow, orange, or red. They can weigh, listen to this, and I don't know if a lot of people know this. Clouds can weigh tens of millions of tons. So clouds are very, very heavy. So again, so it's very, 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 very awesome. So very, very awesome. So they can weigh tens of millions of tons. A lot of people don't know that clouds are actually that heavy. Clouds are enormously heavy. Yet they float. So here are clouds in the atmosphere that weigh tens of millions of tons, yet they float in the atmosphere. So pretty wild there. Clouds can be harbingers of good weather or bad. Their absence can be a good thing after a flooding rain or a bad thing during a drought. They provide relief from heat or direct sunlight, but also trap warmth, leading to higher temperatures. And they do that. Precipitation from clouds helps crops grow and produce visibly and make travel dangerous. They come in infinite shapes and sizes, yet we often recognize more familiar objects or animals. So clouds can come in infinite shapes. So clouds are not just defined to typical shapes. Clouds are infinite shapes. And like Libby points out here, how cool is God's creation that clouds can weigh that much and still float? Yes. Not only do they or can they weigh that much, or do they weigh that much and still float, they come in infinite shapes. That is wild. That is extremely wild to think about. The atmospheric conditions coming together, every different thing, and just infinite. There can be an infinite amount of shapes with the clouds. So to me, again, that is part of God's awesome and beautiful creation. They come in infinite shapes and sizes, yet we often recognize more familiar objects or animals. Isn't that wild? So that is very wild. Clouds can be carried along by winds of up to 150 miles per hour, or can remain stationary while the winds pass through them. So that is wild. So clouds can be carried, or they can be stationary as the winds pass through them. Very cool. They can form behind high-flying aircraft. So airplanes can actually create clouds, or can dissipate as a plane flies through them. So if a plane was to fly through a cloud or a certain cloud, the airplane is going to break up the condensation. The airplane is going to interact with that atmospheric condition, and it can dispel all of that. It can dispel the water vapor inside of that. So therefore, it can actually dissipate the clouds. So if an airplane at certain altitudes, a certain speed, and certain temperatures can dissipate clouds. They are not confined to Earth, but are found on other planets as well. So not only did God put clouds on Earth, he put clouds on other planets as well. So, learning about clouds and how they form to become cloud-wise, and that's what we are learning tonight is how to become cloud-wise. And what you see here is a huge cumulonimbus cloud seen from 38,000 feet. So, as you see here, this is a huge cumulonimbus cloud. So, very awesome stuff. Very, very awesome stuff when it comes to that. So, that is just kind of an overview. We will jump into kind of a little bit more of the meteorology side and climatology side of it and talk a little bit more about how clouds form. So I hope not to bore you too much with this part, but this part plays a key part in knowing how clouds form. So there are so big thing is how clouds form. There are two ingredients needed for clouds to form: water and nuclei. So again, not going to try to bore you with the scientific side of it, but again, it's good to understand and know where they come from. So water, so according to the nuclei, water is always present in Earth's atmosphere in some form. However, water molecules on their own are too small to bond together in the formation of cloud droplets. They need a flatter surface, an object with a radius of at least 1 micrometer, which is 1 millionth of a meter. So we're talking the smallest of smalls that you can get into. So, on which they can condense. Those objects are called cloud condensation nuclei. So we're talking so small. We are talking 1 millionth of a meter. 1 millionth. That is ridiculously small when it comes to that. So these nuclei are minute solid and liquid particles found in abundance in the atmosphere. So these nuclei are just made up in the atmosphere. They are just there. Such as smoke from fires or volcanoes, ocean spray, or tiny specks of wind blown soil. So, yes, so wind blown soil helps create clouds. Smoke from fires helps create clouds. Ocean spray helps create clouds. Things that we wouldn't maybe we wouldn't ever think about help create clouds. So when it comes to that, they are hygroscopic, meaning they attract water molecules and are about 1/100th the size of a cloud droplet upon which water condenses. So again, these nuclei are 1 millionth of a meter. So just the smallest thing you could possibly think of. This means that every cloud droplet has a speck of dirt, dust, or salt crystal at its core. So think of this. Think about this. Think about this for a second. This means that every cloud droplet has a speck of dirt, dust, or salt crystal at its core. Pretty wild to think about that a little speck of dirt, a little speck of dust, a little speck of salt crystal, whatever it was, turned into a cloud. So, very wild to think about. However, even with the condensation nuclei, a cloud droplet is still essentially made up of pure water. So again, it goes back into that, but it helps being the nuclei catches on to the nuclei catches on to the dust or the dirt or whatever it is, and that is how it helps aid in the formation of clouds. So, and this looks at it here. So we have water molecules, condensation nuclei. So Again, that is what's happening in the atmosphere. And then we get into temperature. So, how does temperature play into this? So, temperature's role. The presence of water attracting nuclei alone is not enough for a cloud to form. The air temperature must also be below the dew point. Again, the dew point plays a huge role. The point of saturation where evaporation equals condensation. So again, the air temperature must also be below the dew point. So pretty cool stuff. Remember dew point. Dew point is huge. It is key factor in making clouds. Air can reach the point of saturation in a number of ways. The most common way is through air rising from the surface up into the atmosphere and cooling. And look, if you look at the picture here, you can see as it's rising up from the surface and going up to 600 meters to 1200 meters, you can see the difference from the temperature and the dew point into where they meet at it to become 100% humidity. When it's 18 Celsius and or whenever the temperature and dew point are exactly the same temperature, that equals 100% humidity when it comes to that. So as a block of air, or which is also a parcel, rises, it expands due to the lower pressure. It expands due to the lower pressure higher in the atmosphere. Thank you, Rafael Santos, for subscribing. Thank you so much for being here. Thank you so much for learning about clouds. Thank you so much for trusting in me and again for being here. Thank you, Raphael, and God bless you. Thank you so much. So, as a block of air rises, it expands due to the lower pressure higher in the atmosphere. This expansion results in cooling. So again, as a block of air is rising up, it's a parcel of air, it's a parcel rising up, it expands due to the lower pressure higher in the atmosphere. So the higher you go up in the atmosphere, the lower the pressure it is. This expansion results in cooling. So when the temperature changes due to expansion or contraction of the parcel rather than from heat transfer between the parcel and surrounding atmosphere, this is called the adiabatic process. So for each 1,000 foot increase in elevation that the parcel rises, its air temperature will decrease by about 5.5 degrees until it reaches saturation. This is called the dry lapse rate. So again, a little bit of, again, some of the scientific side of things and some of, it's not really the fun stuff of clouds, but again, it's good to know. And so again, not trying to bore you too much with that, but it does help understand what is happening as the parcel rises. It is expanding, and that is what is helping. So, and again, so once the parcel reaches saturation temperature, which is 100% relative humidity, as I talked about, so it's when the temperature and the dew point are exactly the same temperature. That's when it's 100% relative humidity. So water vapor will condense into the cloud condensation nuclei, resulting in the formation of a cloud droplet. So again, you have the nuclei, and now we're getting into water vapor. So, however, the atmosphere is in constant motion because remember, the Earth is spinning. The Earth is not flat. I will not get into that debate, but I think that there are plenty and many things that prove that the Earth is round. But besides that, however, the atmosphere is in constant motion. As it rises, drier air is entrained or mixed into the rising parcel, and both condensation and evaporation are continually occurring. As a result, cloud droplets are constantly forming and dissipating. So they're constantly forming and they're constantly dissipating. When more water condenses on nuclei than evaporates from them, clouds form and grow. So, again, this is how clouds form and grow off of the nuclei. When more water condenses on nuclei than evaporates. So, as long as there's more water there that's not evaporating, that's from there is when clouds form and grow. Conversely, if there is more evaporation happening, than condensation, clouds dissipate. So if the water vapor is evaporating, that's when clouds dissipate or clouds don't even form at all, period. So so again, this is why clouds appear and disappear as well as constantly change shape. So they're constantly going through this type of a process in the atmosphere there. So pretty pretty cool stuff. And again, a little bit more on the scientific side of things when it comes to that, but it is very awesome to understand what is going on in that process. So it is very very great stuff from that. So again, that was a little bit more of the boring side of the things. But if you're like me, it's stuff that is really great to learn and great to know about because to understand what's going on under the hood or what's going on behind the curtain. So it's good to understand exactly kind of how they start and how they form and where they come from. So again, parcel of air rising is where they are coming from. And again, if there is more condensation, then they clouds will form. If there is evaporation, clouds will either dissipate or clouds will not form. Period. So just remember, smoke, fire, dirt, dust, uh, things like that. So that can play into cloud forming. So all it takes is for nuclei to attach onto that. All it takes is for water vapor. So all it takes is all that good stuff. So again, the littlest things you could possibly think of can turn into a cloud. That's all it takes. Again, dirt, dust, salt crystal, whatever it may be. So pretty cool stuff when it comes to that. And again, if you're like me, I love this. I love the meteorology side of it, understanding what goes into it, how it plays a part, and how clouds form, just like anything else. So awesome stuff. Hopefully you all are doing great. Hopefully you all are having a great night. Hopefully you all are enjoying your Saturday evening. So and just like let me jump back into chat here real quick. Looks like what did I see here? Melanie says, "Not boring, John Boy. Thank you for including those important details." You're welcome, Melanie. I appreciate that. Looks like Say by His Grace says, "Weather information is never boring." Thank you. I appreciate that. Looks like we got Libby saying, yes, once again, God working in the details. Yes, in the very smallest, minute details. Remember, let me make sure I get it correctly here. Again, I remember the top of my head again. So, 1 millionth of a meter. So, that is ridiculously small. So, but again, that is in the details. So again, God is always in the details, even the smallest, minute details. So when it comes to that, so let's jump over to the core four. And the core four is going to talk about the names of the clouds that most of us have probably heard, especially if we've looked at clouds and have studied clouds and things of that nature. So, but we'll jump into that. And then from the core four, there are the basic 10 types of clouds in where they live at in the atmosphere. And we'll look at a cool cloud chart, and then we'll look at color of clouds. So, core four, the four core types of clouds. While clouds appear in infinite shapes and sizes, they fall into some basic forms from in basic forms from his essay of the modification of clouds. So we're talking all the way back in 1803, so quite some time ago. Luke Howard divided clouds into three categories: cirrus, cumulus, and stratus, plus a fourth special type, nimbus. And we will get into them. So, cirro form. A cirrus cloud. This is what it comes from. It comes from the Latin word cirro, means curl of hair. So when we see these types of cirrus clouds, that is what it's referring to. It's coming from the Latin word curl of hair. Composed of ice crystals, cirro-formed clouds are whitish and hair-like. These are the high, wispy clouds that to first appear in advance of a low-pressure area, such as a mid-latitude storm system or a tropical system, such as a hurricane. So, if there is a low-pressure system, mid-latitude storm system, or a tropical system, such as a hurricane, these clouds are going to come before you see the rest of them. So, again, these are indicators. So, again, a lot of clouds that we see are indicators of storm systems or of storm patterns or of different things. So, again, it's good to understand and know that these are precursors to what's coming down the line. Cumuliform, generally detached clouds, they look like the white fluffy cotton balls. So these are the bigger ones that we see in the sky. They show vertical motion or thermal uplift of air taking place in the atmosphere. They are usually dense in appearance with sharp outlines. The base of cumulus clouds are generally flat and occurs at the altitude where the moisture in rising air condenses. So again, the cumulo clouds are the big, fluffy Care Bear type clouds and things of that nature. So those are very big clouds. So that strato comes from the Latin word for layer. So remember, strato means layer. These clouds are usually broad and fairly widespread, appearing like a blanket. They result from non-convective rising air and tend to occur along and to the north of warm fronts. So again, this is telling if you have a warm front in your area, if you have a warm front passing through or a warm front coming through, stratus clouds are going to be an indicator of that. So, again, they result from non-convective rising air and tend to occur along and to the north of warm fronts. So, if you see these, you can know that these clouds are north of the warm front. So, the warm front would be south of where you see these clouds. The edges of stratiform clouds are diffuse. Now we get into nimble form. Howard also designated a special rain cloud category which combined the three forms cumulo plus cirro plus stratus. He called this cloud nimbus. So when you talk about nimbus, he is basically combining cumulo, cirro, and stratus. The Latin word for rain. The vast majority of precipitation occurs from nimble form clouds, and therefore these clouds are generally the thickest. So cumulonimbus, right? That's what we, that's going to be thunderstorms. That's going to be cumulonimbus, right? Clouds. That's going to be your big. That's going to be the big thunderstorm clouds and things of that nature. So I think a lot of us have heard cirrus, we've heard cumulo, we have heard stratus, and we've heard nimble, and nimble gets combined into some of them. So again, very cool stuff. So thumbs up if you all are still having fun. Thumbs up if you are still having a great time. Thank you so much for being here again. Let me know if you are enjoying the content, if you are enjoying learning about clouds tonight. So, and where Um, and where you see clouds, you might have clouds outside your window tonight. You might be a clear night. I don't know. But nonetheless, uh, it's clouds, clouds, and more clouds. So looks like we got Chasing for a Cause in here. So thank you so much, Chasing for a Cause, for being in here tonight. Great to see you. Thank you so much for your support and for your encouragement. I highly, highly appreciate it. Thank you so much. So we're gonna get to the height of clouds, and a lot of times the height of clouds play into precipitation, right? They a lot of people will ask, well, how tall is the echo top? How tall is a cloud? Things of that nature. So looks like Chasing for a Cause says, I was working on my channel. Hopefully, you are getting your channel the way you want it to be. So, hopefully, everything is going good there, Chasing for a Cause. But good to see you in here. Definitely appreciate that. So again, the traditional division between the polar and temperate regions is the Arctic Circle. So Arctic Circle being north, right? Arctic um, by the North Pole, Arctic Circle. Actually, some of Alaska is in the Arctic Circle. Uh, so if you ever travel up to Alaska, um, northern, I wouldn't say extreme northern, but pretty far northern in Alaska, that is inside of the Arctic Circle up there. If you ever travel up there around May and June, and now in July as well, it is extremely sunny up there. I have to go back and look, but I do know that the sun does not set up there for a certain amount of time. So you could go up there. I believe in May and in June, and it'd be like 24 hours of sunlight. So Chasing for a Cause says, I'm hopefully be able to go live soon. I will be out chasing. Gotta get 19 more subs, but I will get there. If you guys have not subbed yet to Chasing for a Cause, please sub to his channel. Let's support him and the community, and let's support him get to where he needs to be. So please subscribe and please support Chasing for a Cause, please. But again, so we got the Arctic Circle in the northern hemisphere, and then we got the Antarctic Circle way down south, and obviously that's in Antarctica. So we have Arctic and we have Antarctic. So we have two different uh, um, things. So two opposite sides, two different sides. So um, and then let's see. So, and then we have the division between the temperature and tropical regions is the Tropic of Cancer. And who remembers Tropic of Cancer from learning about weather in school? And who remembers learning about the Tropic of Capricorn and learning from school? So again, Tropic of Cancer, Tropic of Capricorn. One is at 23.5 degrees north, the other is at 23.5 degrees south. The actual division between these regions varies from day to day and season to season. Between the polar and temperate regions lies the jet stream in both hemispheres. So again, between the polar and temperate regions lies the jet stream in both hemispheres, while the subtropical jet stream divides the temperate and tropical regions. These cores of strong wind decrease the maximum altitude of the tropopause in each region, moving from the equator to the poles. Generally, as the tropopause's height decreases, the elevations at which clouds occur also decreases. So as we look and see, so the polar regions are basically saying, oh, the high altitude there in the polar regions is basically 25,000 feet. That's what we're saying that is high. It's a high altitude there. But if you look at the temperate regions, it gets higher. about 45,000 feet. That is what is used as high. So, and then if we look at the tropical region, 60,000 feet is used in as high. So again, different regions dictate different altitudes and zones for clouds and how and how they are described from being from high, mid, and low. So pretty cool stuff. So the exception is low clouds, which typically have cloud bases within the first 6,500 feet of the surface, but even that can vary. So again, we're going to talk about the three levels of clouds, the three levels in the atmosphere that clouds sit in. So there are clouds that are called high clouds, there are clouds that are called mid clouds, and clouds that are called low clouds. And what the low and the mid and high are separated by is their zones, or what is how far they are off the surface. So again, that's what dictates low, that's what dictates mid, and that's what dictates high. So so uh, the base of cumulus and cumulonimbus clouds can sometimes be higher than 6,500 feet. During summertime, the base of these convective clouds will be well into the mid-level cloud range in the non-mountainous areas of the southwest United States. So again, cumulus clouds bases have been observed up to 9,000 feet over north central Texas, and thunderstorms with cloud bases from 11,000 to 12,000 feet have occurred near San Angelo, Texas. This happens when, despite the dryness of the lower level of the atmosphere, the mid-level atmosphere is fairly moist and unstable. The dryness of the lower level is such that parcels of air need to rise up to 2 miles, and sometimes more, before they cool to the point of condensation. So, we're going to get into, again, like talk about the low and the mid and the high clouds. So, and these are basically the regions. Now, not everything plays by the book, but again, these are just this is a general zones in what scientists and what meteorologists have put these type of cloud types into. So, low clouds are considered from the surface to 6,500 feet. Those are considered low clouds. And then we have mid clouds. So mid clouds, depending on which region you're in, but mid clouds start at 6,500 feet and go basically to in between 13,000 and 25,000 feet, depending on which region you're in. And then we have what are known as high clouds. So this is the third zone. So think of clouds, think of a zone, think of different zones in the sky, and this is the clouds are in these different zones. High clouds are range from 10,000 feet to 60,000 feet. So again, different regions where clouds typically where clouds typically stay within these zones. But again, we know not all clouds follow this pattern, but the majority of them do. The cumulonimbus, though, can go between the low and the high. Cumulonimbus can be super low base, and it can be up to 60,000 feet tall. So cumulonimbus goes across all three of the zones. So yes, so since the jet stream follows the sun with the change of the season, it shifts towards the equator as winter progresses. Therefore, the polar regions expands and the temperature region moves towards the equator. In summer, the tropical region expands while the polar region shrinks, shifting the temperature region towards the poles. And this just gives you an idea of what's happening here with the jet stream and what is going on there. So again, some great stuff there to learn about when it comes to clouds. So, but again, Everybody having fun? Everybody learning about clouds? Everybody getting a refresher about clouds? So far, we've gotten a little scientific. Uh, so now we've just learned about the four types, the core four types of them, and what we look for, the heights of the clouds, and what's driving the heights of the clouds in different regions. If you're in the polar region, if you're in the temperate region, or if you're in the tropical region. Um, so definitely, so definitely, definitely, let me know if we're all having fun. If you're also having fun and you're having a great time. So, uh, definitely am thankful for all of you that are in here. But yes, let me know if you're still enjoying what you are seeing. And if anybody has any questions or comments or concerns, please let me know. And please ask away. Take some time here for if you have any questions. And let's chat about that before we move on to the basic 10 types of clouds that we basically see in the sky every day or at some point, sometimes. So, when it comes to that. Um, but yeah, let me know if you have any questions, any comments, anything cool that you've learned so far about clouds, or that you maybe have a refreshed about, or maybe that's something that you would like to point out about that. So, when it comes to that, uh, I am enjoying teaching you. I am enjoying being with you. So, this is what I love to do. And I'm so thankful and so blessed to be able to do it. So, with that being said, let's move on to what's known as the basic 10 types of clouds. So, what clouds hang out in the high zone? What we know is what's called the high zone, the high level. What clouds hang out there? Well, so we're basically going to look at cirrus, right? Cirrus clouds. Fair weather clouds, nice day clouds, clouds that we see like on a nice, awesome sunny day, cirrus clouds. So, what are cirrus clouds? Well, cirrus are detached clouds in the form of white, delicate filaments, mostly in patches or narrow bands. They may have a fibrous hair-like and or a silky sheen appearance. Cirrus clouds are always composed of ice crystals. So these cirrus clouds are always composed of ice crystals. And their transparent character depends upon the degree of separation as of the crystals. As a rule, when these clouds cross the sun's disk, they hardly diminish its brightness. When they are exceptionally thick, they may veil its light and obscure its contour. But again, cirrus are seen in fair weather. Before before sunrise and after sunset, cirrus are often colored bright yellow or red. These clouds are lit up long before other clouds and fade out much later. Sometime after sunset, they become gray. So these cirrus clouds can be lit up different colors. At all hours of the day, cirrus near the horizon are often a yellowish color. This is due to the distance that light travels through the atmosphere at a low angle. So it's refraction of light um, when it comes to that. So cirrus clouds, I think a lot of us have probably heard that, but a lot of us have probably seen them on many, many nice, warm, sunny days, or even colder sunny, whatever it is, just nice sunny days. We have seen those on. Cirrocumulus. So these look a little bit different. You can tell they look just a little bit different when it comes to that. So thin and white, these clouds look like a patchy sheet of layer arranged somewhat regularly into grains or ripples without shading. Most of these elements have an apparent width of less than 1 degree, approximately width of a little finger held at arm's length. So these things are really uh, the width is super super small. So when it comes to that, so predominantly made of ice crystals, cirrocumulus often form in connection with cirrus or cirrostratus or form a degraded state. These cloud types and are short-lived. So again, you can tell from the difference of the pictures, just a little bit of a difference when it comes to them. But again, cirroclouds, cirrostratus. So again, here's the clouds that are in the high zone. So cirrus clouds, these are in the high level, in the high zone. So again, this is in between 10,000 feet and 60,000 feet, depending on the region you're in. So cirrus, cirrocumulus, and cirrostratus. So cirrostratus is transparent, whitish veil-like clouds with a fibrous hair-like or smooth appearance. A sheet of cirrostratus is very extensive and can cover the whole sky. So these are the very thin ones um, that we also see as well too. During the day, when the sun is sufficiently high above the horizon, the sheet is never thick enough to prevent shadows of objects on the ground. A veil of cirrostratus may have a similar appearance to a milky veil of fog or thin stratus, but it is distinguished by a halo phenomenon, uh, nearly always produced around the sun and moon shining through a layer of cirrostratus. So again, cirrus, but these are cirrostratus clouds. So we can tell a little bit of difference there. We can tell a major difference between the first two and these two. But again, if you see these type of three, these are in uh, the high level. These are high level clouds in the high zone. Again, between 10,000 and 60,000 feet, depending on which region you live in. And uh, these are the tall boys that live up there. So um, when it comes to that, so when it comes to that, so again, cirrus, cirrocumulus, and cirrostratus. Now we will get into the mid-level clouds, the ones that live in the middle zone. So altocumulus, altostratus, and nimbostratus are mid-level clouds composed primarily of water droplets. However, they can be composed of ice crystals when temperatures are low enough. So again, the higher you go up, the clouds are ice crystals. When you start getting to the middle, they can be ice crystals or it can also be water vapor that it's made from. So, um, in Latin, alto means high, yet altostratus and altocumulus clouds are classified as mid level clouds. Alto was also used to distinguish these higher level clouds from their low level liquid based counterpart clouds, stratus and cumulus. So, altocumulus. And my wife is a music teacher, so she understands. So she's all about alto and soprano and all the other fun stuff that makes up singing and everything else. So, but yes, my wife is an awesome music teacher. Uh, so she has been doing that for over, let's see, what year is this? So what, 21 years or something. Uh, so she's been doing it for quite some time. Uh, but yeah, but nonetheless, I just thought that was kind of a good segue into that about alto. So, um, but yes, white and or gray patchy sheets and layered clouds generally composed of laminate plates, rounded masses, or rolls. They may be partly fibrous or diffuse, um, and may or may not be merged. So again, we're talking about alto cumulus. Now, normally alto would mean high, but when we're talking about clouds here, it just alto is actually just differentiating itself from the lower part. So it means it's higher from the lower part. But normally, when you hear alto, you're talking about somebody singing high. as well. So, um, but again, it goes back into the Latin term of that. So, most of these regularly arranged small elements have an apparent width of 1 to 5 degrees, larger than the little finger and smaller than the three fingers held at arm's length. So, not very wide again. When the edge are a thin, semi-transparent patch of altocumulus passes in front of the sun or moon, a corona appears. So this is when we can get a corona. That so uh, when it comes to that, so and lost my place here. Okay, this colored ring has red on the outside and blue inside, and occurs within a few degrees of the sun or moon. The most common mid-level clouds, multiple layers of altocumulus, often appear at different levels at the same time. Many times altocumulus will appear with other cloud types. So these are altocumulus clouds that you see here. So then we have what are called altostratus. Gray or bluish cloud sheets or layers of striated or fibrous clouds that totally or partially cover the sky. They are thin enough to regularly reveal the sun as if it's seen through ground glass. Altostratus clouds do not produce a halo phenomenon, nor are the shadows of an object on the ground visible. Sometimes virga, streaks of rain, is seen hanging from altostratus, and at times may even reach the ground, causing very light precipitation. So, again, these are altostratus clouds right here. So hopefully you all are still enjoying clouds and cloud formations and the layers that the clouds are in. Nimbostratus. Resulting from thickening altostratus, this is a dark gray cloud layer diffused by falling rain or snow. It is thick enough throughout to blot out the sun. Low, ragged clouds frequently occur beneath this cloud and sometimes merge with its base. The cloud lowers as precipitation continues. Because of the lowering base, it is often erroneously called a low-level cloud. But remember, when we see this, it's actually a mid-level cloud. Both altostratus and nimbostratus can extend into the high-level clouds. So, nimbostratus. What is nimbostratus doing here? So, it's the again, it's the gray color, the dark gray clouds that we see a lot when it rains or when it snows. So these are the nimbostratus clouds. So um, this is what's happening there, and I think a lot of us have seen these, especially on gray days, especially on days where there's no sunshine because it's blocking out the sun. A lot of it, majority of it is due to nimbostratus type clouds. So we can all thank nimbostratus for blocking out the sun for us. So not nice, not nice at all. So low level clouds, low level clouds. So cumulus, stratocumulus, uh, stratus, and cumulonimbus. So these are what live in the lower part of the level zone, in the lower level zone. So this is again, maybe this is going from the surface to about 6,500 feet in the air. So these are basically is what's called the low level. Cumulus. I think we've all have seen these cumulus like this before, floating around. It looks like we can almost reach up and touch them as they look so dang low off the ground. Detached, generally dense clouds and with sharp outlines that develop vertically in the form of rising mounds, domes, or towers with bulging upper parts often resembling a cauliflower. So these sometimes are called cauliflower clouds. Don't know if any of you knew that. But if you did, awesome. That is very awesome. So the sunlit parts of these clouds are mostly brilliant white, while their bases are relatively dark and horizontal. Over land, cumulus develops on days of clear skies due to diurnal convection. It appears in the morning, grows, and then more or less dissolves again towards evening. So, but yes, but awesome, awesome stuff. So, looks like Melanie says, "Great job, John Boy. Unfortunately, I have to go now. Thanks, everyone, and good night." Thank you, Melanie, for being here. Thank you so much for being a huge supporter and a huge encourager. Just very thankful for you, your husband, your whole family. So thank you so much, Melanie. God bless you. Just so thankful for you. So thank you so much, Melanie. Definitely appreciate it. So everybody, please say goodnight to Melanie, please. Cumulonimbus. These are the big guys. These guys can stretch from the low level up to the upper level because these guys can stretch from 2,000 to 60,000 feet. They can stretch. So these guys go across all of the levels. And of course, the cumulonimbus is known as a thunderstorm cloud. This is a heavy and dense cloud in the form of a mountain or huge tower. So what we call like towering clouds. See, oh, there's huge towers off in the distance. They're talking about cumulonimbus clouds. Those are huge towers. And the upper portion is usually smooth, fibrous, or striated, and nearly always flattened in the shape of an anvil or vast plume. And of course, once the anvil is happening there, is because the anvil pancakes out and it spreads out because it has reached the tropopause. It has reached the level where it can no longer interact with the weather and the atmosphere. So it has reached the tallest part, the highest part of the atmosphere where weather it lives at. So that's why it anvils out and it pancakes out when it comes to that. So it cannot go up any higher. Under the base of this cloud, which is often very dark, there are commonly low, ragged clouds that may or not merge with the base. They produce precipitation, which sometimes is in the form of virga, against rain. Cumulonimbus clouds also produce hail and tornadoes. Stratocumulus, stratocumulus, gray or whitish patchy sheet or layered clouds that almost always have dark tessellations, honeycomb appearance, rounded masses, or rolls. Except for virga, they are non-fibrous and may or may not be merged. They also have regularly arranged small elements with an apparent width of more than 5 degrees, about 3 fingers at arm's length. So their width, again, is not very wide. Stratus, a generally gray cloud layer with a uniform uh, base, which may, if thick enough, produce drizzle, ice prisms, or snow grains. When the sun is visible through this cloud, its outline is clearly discernible. Often, when a layer of stratus breaks up and dissipates, blue sky is seen. Sometimes appearing as ragged sheets, stratus clouds do not produce a halo phenomenon except occasionally at very low temperatures. So, those are the 10. Those are the 10. Those are the 10 forms, or the basic clouds, the 10 basic clouds that are in the sky at basically all times somewhere on around on Earth. So 10 basic cloud types. And it's so again, we got high level clouds. We got mid-level clouds, and we got low-level clouds. So high, mid, and low. So looks like we got Diesel Weather in here. So thank you, Diesel Weather, for being in here. Thank you so much. Thank you very, very much for being in here. Did I miss anybody else? Let me see here. Somebody's saying hi, Motley. Is Motley in here? I didn't see. If Motley's in here, awesome. Thank you for being in here. Motley, if you are, um, maybe I missed it. Uh, but yeah, so everybody say hi to, if Motley's in here, say hi to Motley and say hi to Diesel. So, very awesome stuff. So, when it comes to that, but again, we're looking at high level clouds. We are looking at mid level clouds, and we're looking at low level clouds. So it's very, very um, cool to understand that these clouds will live in those certain zones. But again, the cumulonimbus will cross each of those three zones. The cumulonimbus doesn't care because the cumulonimbus thinks it's cool and thinks that it's better than everybody else. And it's the one that produces the thunderstorms. It produces hail. It produces tornadoes. The cumulonimbus is not friends to anybody. So, again, the cumulonimbus is not a nice person. So, it's not a nice cloud. It doesn't like to do what the other clouds do. It likes to do what it wants to do. So, Moderate says, I'm still here, John. Thanks for your support the other day. It really means a lot to me and my lady. You're the man and a great soul. Hey, I appreciate that, brother. I appreciate that, Moderate, a lot, man. Definitely, it's all about growing the community. It's all about coming together as one and supporting each other. Uh, so definitely, uh, definitely very blessed to help you out and as well. So, and again, if you guys have not subscribed to Moderate Motley, please subscribe to Moderate Motley. Um, so please help him grow his channel as well. Help Chasing for a Cause grow her channel as well. So um, this is what it's all about in the weather community. It's not about one person becoming the dominant chaser over somebody else. It is about us being in a community and growing the community and helping each other along the way grow. So my outlook is always, if somebody does the same stuff I do, if somebody teaches and they have a channel that is 100 times larger than mine, that I don't care about. That is good for them. That's great for them. I'm actually happy that they are growing their channel and they have blossomed that big to that. So, again, we cannot be scared of people outgrowing us or people outgrowing our channels. We must help each other and we must grow the community and grow each other. So that's that's how it is, because remember, the whole is greater than the one. The one person is not greater than the whole. So again, the whole always outshines. And we are a whole as a community. So, but we are a great weather community in bringing it together. So, thank you to Motley. Definitely great stuff. Check out his streams. Uh, Definitely some great stuff over there. Great content over there. Check out Chasing for a Causes streams as well. Check out her channel as well. Help her, launch that and get that going as well. Because we all need help and we all need support. So, uh, and then we all need a lot of help there. So, um, when it comes to that, so again, those are the 10. Those are the 10 um, basic clouds that live in the high, the mid, and the low level and the low zone. So again, high zone or high level, mid level, mid zone, low level, low zone. So that's how they live. So now we'll move on to cloud chart. So don't want to bore you with this stuff, but we'll go over it real quick, and then we'll look at the chart because the chart is very, very awesome. Chart is uh, very, very cool, very, very great stuff. So prior to the availability of high resolution satellite images like we have today, so this is previous all that good fancy weather stuff that we have now. A weather observer would identify the types of clouds present and estimate their height as part of the weather observation. From those sky condition observations, symbols representing cloud types were plotted on weather maps, which the forecaster would analyze to determine the location of various weather systems. So it's definitely not like it is today. Knowing the types of clouds provided vital information about the atmosphere at each location. The clouds told a weather story to the meteorologist. So remember, clouds are telling a story, and they do. And again, if you know the clouds, you can again, a lot of clouds are precursors to cold fronts or to warm fronts or to weather systems. So again, if you know the clouds, you can know that what's lying behind them. So it's good to know, and those clouds are telling a story. So very great stuff when it comes to that. So check out this picture here. This picture tells a thousand. This picture is awesome right here. So when it comes to this, so uh, this is the Washington D.C. the U.S. Weather Bureau. So if you guys don't know, the U.S. Weather Bureau, okay, that was the name that predates the National Weather Service. So the U.S. Weather Bureau is the National Weather Service, but at the time, the National Weather Service was known as the U.S. Weather Bureau. So if you ever see U.S. Weather Bureau, it is just the predated name of the National Weather Service. So this is 1941 at the National Airport. Cloud heights being measured by means of a daylight ceiling projector. A daylight ceiling projector. This is what was used in 1941. This is wild. But this is the tools and the resources that were available back then to use. So in the 1930s, the National Weather Service standardized codes for cloud forms, and cloud cover according to the International System of Classification. From there, charts were created describing the state of the sky. The NWS cloud chart is a picture of the state of the sky, displaying both individual clouds and combination of clouds. This helps provide a picture of the state of the atmosphere at the time of observation. For example, an overcast layer of stratus, which is ST. So each cloud gets a abbreviation. So you'll see like ST and CI and CB and things like that. So each cloud gets an abbreviation. Clouds mean the atmosphere is stable, implying little change in the current conditions for the next few hours. So remember this. For example, an overcast layer of stratus. So if you see an overcast layer of stratus, it means that the atmosphere is stable. So that's a stable atmosphere. It's not an unstable atmosphere. So it's implying that there's little change in the current conditions for the next few hours. So if if you see stratus clouds around, it is mean that you are in a stable atmosphere environment. Cirrostratus clouds increasing in sky coverage and thickness implies a change from fair weather to possibly rainy or snowy conditions. So again, if you are seeing cirrostratus clouds increasing in sky coverage, and thickness implies a change from fair weather to possibly rainy or snowy conditions. So again, if you know the cloud types and know what's going on there, you can know what might be coming ahead. Um, so very good stuff. Sonia says moderate Molly definitely did share John Boy's stream. Oh, thank you, brother. I appreciate that, man. That's awesome of you, brother. Just got the alert. Thank you, Dylan. Greatly appreciate your support. Yes, thank you so much, brother. I appreciate you sharing. That is very, very kind of you. Very, very awesome of you. I highly, highly am blessed. So thank you so much, there, moderate Motley. I definitely appreciate that. And I did vote on moderate Motley's post he put up the other day about possibly changing his subscriber name from, I believe, Moist to Crew, so maybe the Motley Crew. I voted for Motley Crew just because I think that's an awesome name. And when I do hear Moderate Motley, I think of Motley Crue, the band. So I think that's a freaking win-win situation. I think that's uh, awesome. So I voted for Crew. That's what I voted for. But let's get back into clouds real quick. So some cloud classifications on a cloud chart represent the same cloud type at different stages of development or amounts of sky cover. For example, cumulus, which is CU, clouds of little vertical extent are classified as low 1, but are classified as low 2, and there is moderate vertical growth. A cumulonimbus CB without a visible anvil is classified low 3, but with an anvil is classified as low 9. So again, that's just telling you how things get differently classified. Not going to bore you with that. One thing to remember, clouds are identified based upon the elevation of the observation point. From sea level, altocumulus clouds might be observed over the top of a mountain. However, from that mountaintop, an observation of the same cloud will likely report a stratocumulus. So, therefore, two observers looking at the same cloud can often report different cloud classifications. So again, it's all about where you're at. It's all about your viewpoint, your vantage point, and where you're at. So the exception to this is cumulus and cumulonimbus clouds over a mountain. Even though these low-level clouds typically have bases under 6,500 feet above ground, when observed over a mountaintop, their base might be 12,000 feet or higher relatively to ground level. However, the base of the clouds would be well within 6,500 feet above their location over the mountain. Therefore, they would still be called cumulus or cumulonimbus clouds, even when seen from the ground. The cloud chart below shows examples of these 27 categories. So we will look at this because this is freaking cool when it comes to this. So cool. Let me jump back into chat here real quick. Motley, I just seen something. Yeah, he said not sure what you had to do about the membership name. I don't want copyright from the band. Now I understand that. There are ways you could get around that if you just spelled it with a different, with a couple of W's, or you spelled it with, two T's or something like that. You could get around that because you're not copyrighting off of their legal name, and it's just a play on off of that. But that's like how. But again, that's how you could get around that if you wanted to. But yeah, definitely would be kind of cool if that's what you choose when it comes to that. So, and yes, I do believe that a Motley Crue spells it with CRUE. So I could be, somebody correct me if I'm wrong on that, but I think it's not spelled CREW. So if it's not spelled CREW, you're completely in the good with that. So when it comes to that, so but nonetheless, so we'll look at NOAA cloud wise, right? So we got the Cirrus up here. So we'll go top left. Hopefully you guys can see this. Hopefully it's. Let me see if I can. Okay, maybe blow it up a little bit more. Okay, let me come back down. Stop it. There we go. There we got top left. We got Cirrus. We got the Cirrus again, Cirrus again, Cirrus, Cirrostratus. So this whole thing just keeps going on and on. But again, this is a cool picture because it gives you, uh, because it gives you a great picture of what's going on and what's going through the sky. So again, this is 27 different pictures. This stuff is just really great to go through and to look at this cloud. So I definitely highly recommend looking at this cloud chart when it comes to that. So Moderate says, wait, are you not monetized yet, John? I am not. No, I've only been streaming. This is only like my 10th stream, I think, 10th or 11th, somewhere around there. But nonetheless, no, I am very close though to becoming a YouTube partner. I have the subscribers, I have the videos amount posted, but what I need is the watch hours. So watch hours, I am super close on watch hours, not too far away at all. So um, I should hopefully be there either tomorrow or the next day, be at the hours needed. So very close to becoming monetized. Super close. So I'm extremely blessed and extremely happy and looking forward to that when that happens here. Hopefully within the next couple of days. When it comes to that, uh, so pretty cool stuff. Get out of there. When it comes to the cloud charts, when it comes to the cloud chart, don't be stupid. There we go. Okay. And then we have, so we look at the cloud chart. Look at one thing I just want to point out. So like Cirrus, like these Cirrus clouds are pretty cool. I don't know. I've always thought Cirrus clouds are pretty cool. But let me know in the chat. Let me know in the chat what if you have like a certain favorite cloud or a certain cloud that you like. So the best. Let me know in the chat there what you like there. So um, but I always thought Cirrus were pretty cool. I don't know. Maybe because it's fair weather. Maybe because they're just a little wispy. I don't know. But everybody has the reason why they like certain things. So, Diesel Weather says Mamatis. Yeah, Mamatis are cool. Mamatis are really cool clouds. Yep. Um, definitely. I think Mamatis are pretty cool clouds as well. Anvil clouds are cool, obviously. Somebody's Grace says gravity waves. Yeah. Debbie says cirrus clouds. Yep. But yeah, I don't know. It's just that's what I've liked, and I do like Manus too. And fun fact, like I've said before, I have never seen Mamatis in person, at least that I can recall. Diesel says cumulonimbus clouds are amazing, and they are, yeah. So when it comes to that, um, so if you look down here in this left side here, or I'm sorry, in this like kind of middle down here on the bottom, we have the Mantis clouds here. Talk about fog. Talk about wall clouds. Wall cloud is a rotating lowered rain-free base of a thunderstorm. So, in an area of the strongest updraft under which a tornado may form. So the wall cloud is going to be part of a cumulonimbus cloud. That's where the wall cloud is coming from. Um, Coming from that. There's shelf cloud. There is um, asperitas clouds, virga. There's fog, mammatus, quite a bit of stuff. So when it comes to that, so again, great stuff, cool stuff. When it comes to that, so color of clouds, and I'm not going to jump into all this, but again, it's just basically going to tell you basically about light and wavelength, and when it comes to that, so but again, clouds can be different colors based off of what is called the the wavelength, the light spectrum. So shorter wavelength and longer wavelengths when it comes to that. So when it says so. Omni says cumulonimbus. Yes, cumulonimbus. Yes. So wall clouds are going. So cumulonimbus is what is going to um, that's where the tornadoes come. That's what tornadoes form underneath their supercells. There's going to be cumulonimbus is when it comes from that. So a wall cloud will form underneath that. So a wall cloud will form underneath that cumulonimbus. That is what a wall cloud is forming out of. So, but yes, so cumulonimbus for your Omni there, yes, is what is happening there. So again, the color of clouds. Again, clouds can be different color because of the wavelength of light. You're welcome, Omni. You're very much welcome. So again, we're looking at gamma rays, X-rays, ultraviolet, infrared waves, microwaves, radio waves. So again, it's a light spectrum. So as a light wave length increases, its energy decreases. This means that light waves that make up violet, indigo, and blue have higher energy levels than the yellow, orange, and red. So again, we're talking at a prism. We're basically looking at rainbow. We're looking at different things there across the light spectrum, light wave spectrum. So just kind of cool information here. If sunlight is white, why is the sky blue? The color of the sky is a result of light bouncing off gases in the atmosphere and what is called Rayleigh scattering, named after physicist Lord Rayleigh. The atoms and molecules comprising the atmospheric gases are much smaller than the wavelengths of light emitted by the sun. As a result, collisions cause the relatively larger wavelengths to scatter unequally, with shorter wavelengths scattering more than the longer ones. So, again, just really great stuff that's going on here. Just going to tell you a little bit more scientifically and about why, if sunlight is white, why is the sky blue? And again, it's because it's a result of bouncing off of gases in the atmosphere. So that is why. So, but again, it all has to do to that. So very, very great stuff. And then it's just going to be talking to you a little bit about what it's named after, color perception, things of that nature. So again, clouds can be different colors. So when it comes to that, so again, basic of clouds there, at least from NOAA. When it comes to that, so clouds. So again, clouds can be different colors. Clouds live in different zones: mid, high, low. 10 types of basic clouds, and basically They're in the four groups, but there's 10 types of clouds when it comes to that. And again, clouds can let you know of certain weather that's coming at you. So a lot of clouds can be precursors of what's coming. If you see a shelf cloud, you definitely know you're in for a high wind bag event. You definitely know that you're facing some very, very strong straight line winds. You're going to be facing devastating winds if you see shelf cloud or roll cloud or things of that nature. So if you see a wall cloud, you definitely know that there is potential for a tornado to form. Doesn't mean that one will, but there is high potential if you do see a wall cloud for a tornado to form. So different indications. So things will give you indications of what's happening. So if you know some of the clouds and know some of the cloud formations, that's really really good for that. Uh, so yes. So definitely, clouds are what are very. All right. What should I say? Clouds are don't usually get the love in the weather field that they probably should. So, um, because I say that, clouds dictate weather. Clouds, obviously um, form weather, certain weather patterns, certain weather things. So, again, clouds just do not get the lot of love that they probably should in the weather community here. So, when it comes to that. But again, clouds, and more clouds in that. So, when it comes to that, so very great stuff there. Very awesome stuff when it comes to clouds. And again, there's the Mammatus clouds that was mentioned earlier. Those things are pretty freaking cool looking. Those are awesome looking when it comes to that. We'll take a look at just briefly here. This just showing the clouds that we talked about. But there is like these Mammatus clouds are so cool. It's like I don't even know what you want to call it, like a sack like and everything else like that. But pretty freaking cool looking for the Mammatus clouds. Those are pretty awesome. So when it comes to that, so really really cool about Mammatus. Um, There's also some ones that are called. There's also the called lenticular. Um, so that's another one. Uh, these unusual clouds often look like flying saucers in the sky. So who have seen these types of clouds? Lenticular clouds. That's what these. That's what those are called. So they are formed as air blows over a mountain range, creating downstream ripples. So you'll see these around the mountain ranges. So I don't live near a mountain range, so I don't see things like this. But how many have seen lenticular clouds? So, God of all Slowpoke Gaming, thank you for being here. Appreciate that. Thank you for tuning in. Thank you for um, being here, for being a supporter. Thank you so much. Appreciate that. So, thank you to everybody for who is watching right now on Twitch. Thank you to everybody who's watching on YouTube. Thank you to everybody who's watching on Facebook, and thank you to everybody who's watching on Kick. So again, multi-streaming across 4 different platforms, and looking to add in a couple more as well here eventually too. So again, cool stuff. Again, that is the cloud session for today. That is clouds basically in a high overview nutshell, to kind of give you that, that big elevator pitch, and that again, that 60,000 overview look of what clouds look like and what clouds are. So I hope that you guys have enjoyed learning about clouds, learning about what levels they're in, how they can help predict weather that's coming towards us, how they just play a part in weather altogether. So it But again, clouds are cool to look at, man. I don't know if you guys, some people are cloud watchers or cloud gazers. How many in the comments? Let me know in the comments if any of you guys are cloud watchers or cloud gazers and who love to look at clouds and different formations. And because I know there's a lot of people that do like to go cloud gazing. So when it comes to that, Chasing for a Cause says, I love clouds. Uh, Say by His Grace says, great job, Professor John Boy. Seriously, you are so much appreciated for your time and effort. Thank you. Thank you so much. I definitely appreciate that. Thank you. Um, that is awesome. Yes, thank you. That means a lot to me for sure, definitely. But yeah, let me know in the comments. Let me know in the comments if you are a cloud gazer or if you like to go out and look at clouds and um, and see what's going on out there. So Diesel Weather says clouds are amazing and Mother Nature's art. Yes, clouds are cool. And remember that we learned just a little bit ago is that cloud formations are infinite. Cloud combinations can be infinite. The way clouds look can be infinite. So that is wild to even think about. So that is that a cloud formation can look infinite the way that it looks. So um, Saved by His Grace says, yes, I really enjoy looking at clouds and taking pics and vids. Yes, I agree. Yep. And okay, Jason for Cause says I subbed. I believe that is to Diesel Weather, if I'm not mistaken. So, um, but again, yes, if you guys have not subscribed to Diesel Weather, I would highly suggest to subscribe as well. And again, if anybody in here has not subscribed to Chasing for a Cause, please subscribe to her channel. Um, and as well to Moderate Motley as well, Diesel Weather as well, to everybody in the chat. So I would just say everybody subscribe to everybody who's in the chat because even if people don't make videos, it's always good to subscribe to each other. So um, Tammy says this has helped me so much. Remember a lot of information. Huge thank you, John Boy. You're welcome. Thank you. Um, definitely, definitely when it comes to that. So. Because like me, like and what I would tell you guys is, if you're not familiar with the way that YouTube works, when you get subscribers on YouTube, YouTube only tells you the subscriber's name if that person allows their if their subscriptions are public. If their subscriptions are private, you don't ever know who subscribes to you. So, so if I know somebody has subscribed to me, or if I see it, I will go and subscribe to them because it should be a one for one when it comes to that. But again, YouTube only tells you who subscribed to you if that person has public has public subscriptions on. So if your subscriptions are set to private, whoever you subscribe to will never know that you subscribe to them. So, but yes. So, but I highly recommend that if anybody ever subscribes to you and you know who it is, um, definitely subscribe to them back. Saved by His Grace says, everyone, I must get some rest. Thank you so much, Saved by His Grace, for being here. Thank you so much. You are such a huge supporter and a huge, just very awesome, a huge supporter, huge encourager, huge, everything. So just thank you so much, Saved by His Grace. God bless you. Hope you have a great night. Um, and yes, hope you have such a great night there. Thank you so much. But yes, definitely if you are, um, looks like Daddy Diesel is now following. Thank you so much. Appreciate that. Thank you. That is on Twitch. So thank you so much there, Daddy Diesel. Appreciate that. Thank you. And if you guys haven't yet, if you guys have Twitch or you have Kick or you have whatever, please make sure to subscribe. Please like, follow, subscribe, whatever they use different lingo. Some say follow, some say subscribe. It's basically just it's all the same stuff. So please follow, please subscribe, please whatever the heck they call it. Um, Diesel says, followed on Twitch, waiting to change my name. I'm a dad of twins. Nice. Nice. That's awesome. Uh, that's very cool. I appreciate it, brother. I appreciate it, man, so much. I appreciate it. That is awesome. So, uh, yeah. So I just started streaming to Twitch and Kick. About I think this is my third or fourth time. I think it's the third time. So just starting off, kicking off on both of those platforms and Facebook as well. So uh, when it comes to that, so but yes, definitely am trying to grow the platform, trying to grow across multiple platforms there. So when it comes to that, so um, Tammy says, "Oh wow, it's already midnight. I better get go as well. Catch you on next stream." Thank you, Tammy, for being here. Thank you so much. Definitely appreciate that. That is very, very awesome um, of you, Tammy. Such a great supporter, such a great encourager. Very awesome of you, Tammy. God bless you. Thank you so much for being here. So, when it comes to that, so you are awesome, Tammy. Again, always thank you so much. Um, but yeah, definitely appreciate all of you. And, uh, it's just very, um, it's very it does take a lot of dedication and commitment, and there's other streamers obviously in the chat who can talk about that. It takes a lot of commitment to do something like this. So I'm very blessed though to do it and everything. I'm just so happy for it. So um but yeah, and that's why I'm trying to get into Twitch, because I'm trying to get into Twitch and into Kick, because as you know, there's not a lot of weather people on those platforms. Again, it's mainly like gamers and DJs and some other type of other things. So uh, that's but yes, I'm trying to get in over on Twitch as well uh, to grow the platform over there. And again, of course, we know that what Twitch is mainly for. We know what Kick is mainly for, but there is room for everybody, and there's room for weather over there. And so yeah, so it's really good to push those platforms. Thank you, Saved by His Grace. Thank you. Have a great night. Thank you so much. Appreciate that. Um, but yeah, so I'm looking. Yeah, again, it's. I would definitely, if any of you haven't, I would definitely look into streaming too, or on Twitch or Kick as well, and because you just there's room for it, and there might be a growing need for it, right? There might be people who might be playing games on there, and then all of a sudden they hear a crack of thunder, or they see lightning, and then they can just jump on over to a stream on Twitch or something. So there's always a need on all those platforms, for weather streamers. So um, but thank you, Omni. Appreciate that so much. That's very awesome. Thank you for that. That's very awesome. Very cool. Um, Diesel Weather. Thanks, Debbie, John. You and John McKinley have such amazing communities. That's how I found you, and I'm trying to learn as much as I can about weather. Nice. Awesome. Awesome, Diesel Weather. Awesome. Oh, nice. Thank you. Thank you. Got raised. Thank you, Omni. Appreciate that. Awesome. Awesome. That is awesome. That's awesome, Diesel. That's awesome. That's awesome, Omni. That is very awesome. When it comes to that, so but yeah, it's it's this is what I do. This is what I've been studying weather. I have been in weather for, like I said, over 20 some years. So I mean, I know a lot. I've studied it. I have immersed myself in it. Um, it is it is such it's and there's it's always learning, because there's always things that are evolving. And so again, if you're just new to weather, or you're starting out in weather, or whatever it is, I gravitated towards. So I know a lot about all kinds of weather, but my main expertise is in severe weather. So when it comes to tornadoes and severe thunderstorms, hurricanes, things of that nature, that is where my expertise plays into. Um, but yes, and I've been studying severe weather for, again, over 20 plus years. Um, and not just like, I mean, like really studying it, really getting into it, the science, climatology, meteorology, the whole nine yards, the whole, just, you know, stuff that will bore you, and stuff that will, most people don't like, so, um, but in order to understand weather, in order to understand how things happen, you have to get down and dirty into the weeds. Because there's things I haven't talked about yet, like thermodynamics. I haven't even talked about that yet when it comes to weather. There's a lot of different things that I haven't talked about yet when it comes to weather. And there's just a lot of things that go into it. But yes, I love weather. I'm passionate about it, but not only am I passionate about it, I'm very, uh, what do you want to say? Just even beyond passion, right? So, but again, I am hopefully providing accurate, or to you guys, at least I hope you guys believe that I am providing accurate, trustworthy information that you can trust, and be a trusted, reliable source for you guys, and somebody that you can, help lean on. Um, and obviously, I learned from you guys as well too, because again, even though I've been studying it for a long time, I don't know everything. Just like somebody who's been doing it for 40 plus years, they're never going to know it. You're never going to know everything in the weather field. You're just not going to. There's just way too much, and it's always evolving. But if you, like if you hone in on a certain craft, or a certain, severe weather, whether it's tornadoes, hurricanes, or all that, or you hone in on radar, or you hone in on, clouds, or you hone in on whatever it is, uh, a lot of people just kind of sink their teeth into one, place, in weather. So some people sink their teeth into learning about the atmosphere. So some people would just become like atmospheric scientists. Well, they'll just study the atmosphere. There are people who will just study tornadoes and be tornado scientists. There are people who just study lightning and be, you know, I don't know if they're called lightning scientists, but people that just study lightning all the time. A lot of people just they kind of hone in on one certain part of the weather. And again, that's where I honed in on severe weather and tornadoes, again, severe thunderstorms, hurricanes, earthquakes, things of that nature. That's what in radar. Radar's always interested me too. Uh, I don't consider myself an expert in radar, but I definitely consider myself uh, uh, very far advanced in radar. So I actually don't like the term expert in anything, because I think that the term expert actually, when people use the word expert, it can actually take away from growth. It can actually take away from learning, and take away from growing. Because sometimes people get what's called the expert complex. And the expert complex means that once you think you're an expert on something, you think that you think that you don't have to learn anymore, and that you know everything. So sometimes I actually don't like using the term expert when it comes to that. So just be very careful when it comes to that, because you definitely always want to know that learning is obviously the most important thing. Is to obviously continuously keep learning. Uh, so so I like to always just say advanced. When it comes to things. So um, when it comes to that, so Libby says I have gotten into taking pictures of towering storm clouds in the distance and then taking screenshots showing how far those storms are from my current location. Oh, that's awesome. That is pretty cool, Libby. That is awesome. That is so cool. That is cool. Diesel says, I falling in love with severe weather. I joined Skywarn and the Spotter Network. I'm addicted to learning and helping people. Nice. Awesome. Thank you, Diesel. Skywarn is a great program, and that is awesome. So, um, Spotter Network is awesome. Um, Definitely um, take whatever classes you can. I definitely recommend taking any type of spotter training, spotter classes. Whether it's Skywarn or whomever else. There's a couple other different entities that offer types of weather spotting and things of that nature. So, but definitely whatever you can learn about, severe weather, whatever you can learn about, um, I definitely say go for it and do it. And and there's a lot of people that so whatever you can do to further your learning, that's awesome. Um, or become like a certified, like you said, like a certified weather spotter or something like that. And because we always need more weather spotters in the community. Always. That's what's I mean. Weather spotters serve such a huge purpose when it comes to the weather. It actually kind of goes under the radar sometimes how much that weather spotters are needed out there. So and because the radar can only see so much. The radar can only see so close to the ground. When the radar scans, it scans due to the circulation of the Earth and due to the roundness of the Earth. The radars that we currently have in place uh, cannot see below a certain feet. So we need weather spotters on the ground. So again, weather spotting is um, it's a great thing. It's an awesome thing. So Diesel says I saw a chaser not long ago see a tornado in a storm that wasn't even tornado warned, and without the report, imagine how many people would get caught off guard. Yes, it happens actually quite a bit. It actually happens very very frequently. Uh, More than what uh, you would probably think. But again, it happens very, very frequently in weather because again, the 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 radar is only scanning up to it starts at about 3,000 feet. So I mean, the radar is not really seeing below 3,000 feet. So when you look at that, um, you're looking at there's a huge um, thing of what's happening between 3,000 feet and not. So that's why we need storm chasers out there looking at the sky and looking at everything else. So it's very yes, but yes. So tornadoes, um, yes, it happens a lot. Unfortunately, it just happens a lot because of the limitations of the radar that we have. And again, the radar that we have is a WSR's 88s, which is a weather surveillance radar 1988. So yeah, and there are radar holes, and there are, as Libby just pointed out, there are radar holes. There are blind spots. There is the cone of silence when a storm gets close to a radar, and so there's always in the radar systems that we have set up today. There's always the way that it's going to be is there's just going to be times when tornadoes go unwarned, when severe thunderstorms go unwarned. And again, that's not due to the people at the NWS's fault. That's not due to them being slacking or not doing their job. That's just due to the limitations in the radar that we have. That's just due to the systems and tools that we have. So unfortunately, there are a lot of tornadoes that do not get tornado warned. And like Libby says, and that is why spotters and chasers are so important. Yes, absolutely, 100%. Spotters are and chasers. Chasers are basically spotting too. Spotters are basically chasing when they're out there and look. So definitely huge play a huge key role, and it kind of bridges that gap to where the radar can't see at, and it helps the NWS have more eyes and better eyes on the ground when it comes to that. So, but again, that's the data, that's the radars that we have in place. So that's the radars that we continuously use on a daily basis. But again, yes, definitely having spotters and chasers a function of having those eyes where the radars can't see at. But again, obviously spotters and chasers aren't going to be in certain areas at certain times. And then again, unfortunately, the radar is not going to pick it up. And then, there's going to be a tornado on the ground that never gets warned. And so it's just, unfortunately, it's the way that it is when it comes to that. So it's very, very um, crucial to have spotters and crucial to have chasers on the ground there. So definitely recommend taking Skywarn class, taking any type of class to become a weather spotter when it comes to that. Um, so yes, definitely, and definitely obey. Definitely obey all you know law enforcement things of that nature. So Diesel Weather says, John, a question for you. Why do you think Illinois has a huge spike in tornadoes this year? So, great question. As I live in Illinois, I am just right. Well, I just say I'm in Chicago. I'm just in the south suburb of Chicago. So, basically, Chicago. Great thing. So, what happens this year? So, Libby says there's also the factor of QLCS dropping in the middle of radar, making it swipe. Uh, Yeah, I did I read that right? There is also the factor. Let me make sure I read that right, Libby. There is also the factor of QLCS dropping in the middle of radar, making it swipe. Okay, I understand what you're saying. Yeah. Wait, is that a question or is you just? I don't know. I'm gonna make sure I'm reading that correctly. So I think you're saying that sometimes the QCS will you're talking about a tornado popping up out of the QLCS um, during its sweep. Is that what you're saying? I don't know. I don't know. Maybe I'm not deciphering that right. Please let me know, Libby. Either way, let me know. But to get back to Deezer real quick, uh, okay, Libby says meaning that QCS don't get warned as quickly because of when they drop. Yes, understand completely now. Yes, what you're saying completely. Yes. So sometimes, yes, that will happen a lot. So you will have a QLCS, MCS line that's pushing forward, and they're dropping, fast, quick spin up tornadoes, and depending on where that sweep is at in the radar, again, the NWS can only utilize, the most recent images and the most recent scans. So depending on where that at, there already could have been a brief tornado that went down and came back up before the next scan even comes in. So you just don't know. How quick. So yes, great point, Libby. Definitely, definitely a great point there that you pointed out there. But get back to Diesel. Diesel. So your question, great question. Why do I think that Illinois had so many tornadoes this year, or has had so many this year? So we have smashed our state record already, and we are only, not even 6.5 months of completed time um, of the year yet. So this is what has happened a lot. A lot of the systems that have normally set up normally off to the west a little bit more have kind of gradually come off to the east a little bit. So the parameters in the setup this year have just kind of almost honed in on Illinois instead of honing in on like Iowa and Oklahoma and Kansas and Nebraska. So it's just by sheer setup of the systems. That's why a lot of tornadoes have happened in Illinois. Uh, to get down to the weeds of it. That is one of the main reasons why. It's just to have where the setup has taken place that day and during that day. And again, that's just due to a lot of way that the setup has taken place, the way that some of the troughs have ejected out of the Rockies, the way that some of the way that the warm front has risen, in certain storm parameters. So it's just a lot of things there. But again, when it comes to just the setup has tended to be more eastern this year a little bit, and that's why basically Kansas has got nothing. That's basically why Oklahoma has got nothing all year. Is because the setup, like usually when the cold fronts come out, and usually when the systems push through, they will set up a little bit further off there to the west, and that is what will drive them. Drive the Oklahoma tornadoes and drive the Kansas tornadoes. So again, the setup, just where the setup has been. And unfortunately, the setup has set up a lot this year, right around Illinois, and Illinois is taking the brunt of it. So hopefully that explains it, Diesel. But again, a lot of it is just the main thing is just where the setup has happened this year. Diesel says here in Indiana we are in top 5 year records. Yeah, I think you guys are about like 77. I think I saw or something. Uh, I think you guys, yeah, I think I saw like 77 or something, or somewhere close to that. So, um, but yeah, so and again, I'm originally from Indiana. Diesel, where are you from? And if you, I mean, if you want to, you don't have to obviously, say where you're from. But I'm originally from South Bend, Laporte, South Bend area. So in Indiana, that's where I'm originally from. Um, Omni says it's been horrible for tornadoes here in Michigan since like 2024. Uh, Diesel says I'm from Terre Haute, living near Lafayette. Okay, awesome. So Terre Haute, very familiar with that, and Lafayette, very familiar with that as well. Lafayette or West Lafayette is Purdue University area. So when it comes to that, um, when it comes to that, let's see. We had Omni was talking about that. Uh, and then we have Libby says Illinois has been passing them along too. Yes. Uh, Libby says Michigan has been spreading their tornadoes around this year, including the UP. The UP is kind of um, that's a place that like never hardly gets anything up there. So if you remember earlier in the year, like around in April this time, Wisconsin got it nailed quite good in the early part of the severe weather season. So Wisconsin took a very big hit a couple times. So Omni says, I live in Kalamazoo and we've had tornadoes at least 3 years come close, including the Union City EF3, F4 tornado this year. Oh, wow. Oh, yeah. I forgot about that Union City one. Yep. Um, yeah. Yeah, it seems like Michigan is too is like a random like spot sometimes, like where it'll get yeah, I don't know. It's just kind of it's just where it's just kind of strange on how it's all sets up, right? And when it comes to that, so it's very but yes, Michigan seems to get it. I know that what was the other one? Sometimes Ohio too, but yeah, Michigan sometimes is like a weird one. Like sometimes Michigan will um um Diesel says, John, don't tell me you're a Notre Dame fan, are you? Yeah, actually, I am a Notre Dame fan. Yes, but Notre Dame in football, but in everything else, like basketball, when it comes to college and stuff like that, I am an IU. I've always been Indiana University basketball, and then Notre Dame football. So that's how it's always been. Although IU football obviously has turned it around, and IU football just won the national championship earlier this year, back in January. So um, when it comes to that, but yes, IU football has made a huge turnaround. So IU is not a football school. IU is is and pretty much has always been a basketball school. But the last 2 seasons, IU has been turned around into a football school. So you just never know with college sports, and why that is nowadays. For why things like that happen nowadays for is because of the NIL deals and is because of the transfer portals. So now a lot of times you can now see a lot of schools that were once basketball schools turned into powerhouse college football schools. So uh, when it comes to that, but yes, definitely when it comes to that. But yes, definitely. And if you look at, so let's get back to Michigan. Michigan is in this, and some of you might remember, some of you might not, but there was actually an F5, well, an EF5 now, as it's rated on the Enhanced Fujita scale, in Grand Rapids. So Grand Rapids has actually seen an EF5. That's one part of Michigan that has seen an EF5, and also the Flint EF5 as well too. As well. So Michigan is has seen its fair share of some pretty bad tornadoes when it comes to that. So, but yeah, Michigan just I think sometimes people think that like the lake is going to like help in them, and that's like here in Chicago. A lot of people think like, oh well, we got the lake. The lake's going to help us, not get tornadoes or not get this or not get and it's like no, the lake is not going to do anything. The lake is not going to. Uh, the lake is just there. There's nothing that's stopping a supercell from forming to the southwest of Chicago and heading northeast directly downtown. There's nothing stopping it from doing that. Uh, and in fact, like I've mentioned before, um, is that Chicago actually sees um, quite a bit of they actually see a few tornadoes, not within the city limits, not like downtown, but there are tornadoes pretty much every year in Chicago and in the city limits. So or if not every year, like every other year or something. So they're not uncommon in the within the city limits. They just don't see them downtown because downtown is right on the coast of Lake Michigan. So um, the Portage tornado was something. You talking about the Portage, Michigan tornado? I think I remember that one from like a couple years back or something. Or I think I remember that one. Diesel said y'all in Chicago had an interesting weekend last week with the weather. I know we had an interesting week just with it being super hot and it was like 100 and some degrees a couple like couple days and everything else. So that was kind of crappy. to say the least. But I am a hot weather guy, so again, I'd rather it be 100 and plus some degrees than for it to be 10 degrees or 20 degrees. I do not like cold weather, even though I live in Chicago. And again, it can get freaking cold, so much snow and everything else. So I much rather have it right now where it feels like 100 degrees. I'm cool with that. So not I'm really a cold, not really a cold weather guy. So even though I love Antarctica, but I am not really a cold weather person. So when it comes to that, but yes, it is. Um, awesome. It is. Weather is awesome. To get back on the whole weather point. Weather is awesome, and it touches everybody, whether people want to believe it or not. Everybody is touched or affected by the weather in some form or another. Uh, when it comes to that, so and you would be completely shocked at how many people are not weather aware, or people who are weather unaware. It is um, actually very, very um, kind of alarming at how many people are just so not weather aware. And how many times, and let me know in the comments, how many times have you seen a tornado video, or you've seen a video of somebody driving and they're just completely oblivious, and they're driving right into a tornado, or they're driving right into into a derecho, or they're driving right into hail, or they're walking and they're walking, they're doing whatever, they're just completely oblivious. They're either completely oblivious or they just don't care. And it's like, and it's really kind of troublesome when you think about it. And it's like um when you because you look at people, and this is what I teach people is, don't follow after those actions. Like, because you'll see people out there and there'll be a tornado around. They'll be, and they don't even know what they're doing. They're just driving. Like, they don't even either care that the tornado's off and just in front of them, or they're just oblivious. But don't be like them people. Don't be out there on the road or the street and think that you're just going to be okay because there's other people out there. That no, that is not that is not what you should think about like that. So definitely do your best to be weather aware. Definitely teach and help other people, your friends or your family who might have not, who might not be weather aware or who might not care. And they'd be like, oh, it's a thunderstorm, so I'm just going to go drive and I'm going to go down to the store, or I'm going to go do whatever. And you never know. There could be a 70-mile-an-hour wind. There could be a tornado lurking, something. So just got to get people more weather aware and just kind of just more weather like respect of it. So, but I know that's easier said than done when it comes to that. So it's you definitely have to respect the power of God and the power of the weather. Obviously, um, the weather that He has created. So when it comes to that, for sure, definitely. So, and it's definitely something that you don't want to take for granted. It's definitely something that you don't want to take lightly. And again, obviously, too, I, just like everybody else too, would tell you, please, please never, ever, ever park underneath an overpass or an underpass or whatever you want to call it, a bridge, whatever terminology you want to use for that. But do not park underneath that. Do not get out of your car and stand underneath it. Do not get out of your car and go up underneath the girders. Do not do that. Do not, for certain reasons. There are many reasons, but the main reason is well, one, you don't want to block traffic and block everybody to the back, and then all of a sudden you create chaos from behind and you stopped and everything else. That's one of the main reasons. The other reason is that the wind actually as the wind goes in and gets into a tighter spot, the wind actually accelerates through that spot as it goes condenses down, it gets tighter and tighter. The wind actually accelerates underneath that bridge. Um, so definitely, so not only are you causing a backup in traffic, not only are you causing safety issues, you are now actually facing stronger winds than what you would have been facing had you not been underneath that bridge, overpass, underpass, whatever you want to call it. And a lot of that stems from there is a video. I believe it was the Andover one. It was somewhere out of Kansas in like in the early 1990s. There's a video of a family that tried to outrun a tornado. They couldn't, so they stopped underneath the overpass. They got up underneath the girders, and it's a pretty wild video to watch. Now they all survived, but that tornado they said that passed over them, I think they said it was like an EF2, an EF1 or whatever. So it doesn't really paint the whole picture of what can happen. So they didn't all end up surviving. I would highly recommend watching that video if you guys haven't yet. Um, but yes, it's from the early 90s. It's in Kansas. I'm sure you can find it on YouTube. But that gave a lot of false hope to people out there driving underneath overpasses. And if you even watch Reed Timmer, who is like, obviously like the most well known storm chaser in the world, if you even watch him, his early chase of when he chased the pretty much one of the strongest tornadoes on Earth, the Breach Creek Moore tornado in 1999, the EF5 there, when he chased that, he got up underneath an overpass, and he will tell you to this day that that was not the right decision and the right choice. But he did do that, and that was again in 1999. I believe he was a student at University of Oklahoma at that time. But there is video of that. Um, so yes, so please do not go underneath or park or stop or do whatever underneath an overpass when it comes to that. So because you're just going to make the situation worse for everybody and anybody. So um, Libby says uh, his video from that day is what does that say? His Yes, his video from that day is a bit crazy. Yes, it is. It's great. It's great stuff to see that the camera work and the chasing and everything. Yeah, but a lot of wild stuff that day for sure. That day will live in infamy for tornado type day. So uh I'm just saying, not saying I've never done it, just saying. So I'm just saying I don't think you should go under an overpass even when there isn't bad weather. Kind of sus. Yeah, you probably shouldn't be hanging out underneath overpasses, even when it's bright and sunny and everything else. Probably not the safest spot to be hanging out in. Um, when it comes and you don't ever know, you don't even know what's underneath there. So probably not the greatest spot to be in. But hey, you know, people do what they want, man. So when it comes to that, so but yeah, definitely that. Definitely again to get back to the whole weather thing, right? So the whole weather thing is, yeah, feed, fuel your passion, feed your passion, right? Feed your desire. Keep learning, keep striving, keep to learning more about weather, to learning more about different parts of weather. There's a lot of cool things. Like there's space weather, right? That's gonna be a whole nother um teaching of mine is space weather. It's like uh it's a whole different type of thing. and it's really cool. Like once you dive into it and you learn about it, and learn about like like coronal mass ejections and plasma and all this other stuff. Like once you learn into like space weather, there's really cool stuff. When it comes to that. Just learning how the weather just affects different people at different times. So I mean, again, feed your desire, feed your enthusiasm, feed your passion for weather, and ask questions, and uh, you know there are no stupid questions, and uh, that's the way you learn. Ask questions and keep feeding that, and and uh, give yourself fuel, fuel for what you are learning and what you want to learn when it comes to that. So, and there's so many things. So Diesel says, so when people talk about straight line winds, is that referring to microbursts? It could be, but not always. So straight line winds, we're talking about, you get downburst, right? So, and the straight line winds is basically saying, okay, it's not from a tornado because a tornado is circular winds. So, um, so what you so you're gonna get downburst, but inside a downburst. So when you have straight line winds, you have downbursts that come out of the storms. The storm's energy is pushing all the energy forward, and it comes in a fast form. What's called a downburst. But inside a downburst, but not always, are what are called microbursts. So the microbursts are a downburst. They're just a very smaller, tinier form of a downburst. But because they're smaller and more concentrated, they are actually stronger. They can have stronger winds because of the smaller concentration. So, uh, so yes, straight line winds uh, can also be microbursts, but not always. But they will be downbursts. Straight line winds will be downbursts, but not all the time do downbursts have microbursts inside of them. So, but again, microbursts usually do a lot of the most damage because microbursts you will see again it's this quick, fast, strong, tight area of energy being released. So that's why when that microburst slams into like a forest or it slams into a bunch of trees, you'll just see all those trees just knocked over because that's that microburst concentrated just on that area. So and again and again also too if that microburst it hits a home or it hits structures, again you'll see the most damage because of that area that it is focused on in the area that but again that's why microbursts are dangerous because again they're over a small area, but because of the intense tightness of the of the wind, that's where the most damage comes from, is the microburst. So, and then on the outside of microburst is called macroburst. So macroburst is what you would think. It's the inverse of micro. Micro's on a small level. Macro's on a big level. So usually the damage from a macro burst usually is not quite the same as a micro because a micro is more confined, smaller boost of energy, more. But macro bursts can also cause damage as well. So there's micro and there's macro, which are all part of what are called downburst. So and again it's called burst because it's quick and it's energy being released out from that storm. Uh, so, but yeah, so yeah, yes. So straight line winds can be there could be some microbursts in it, but not always. But there will be the downburst that come from the straight line winds. And again, it's straight line because it's not from a tornado. It's just winds from thunderstorms or a thunderstorm. But usually straight line winds usually come from a multiple linear setup of thunderstorms. So linear just means in a straight line or just in a line. That's what linear means. So you'll hear like storm mode. So storm mode, you'll hear like storm chasers talk about, or you will hear meteorologists talk about, like, well, I wonder what the storm mode is going to be today. Is it going to be a linear storm mode, or is it going to be a discrete storm mode? So a linear storm mode means that again, all of the storms are either going to line up in a line, and it's going to be a one big line like a bow echo, or it's going to be, um, something in the form of that. So that's your linear setup. Discrete is the opposite of that. Discrete is saying, oh, all these supercells are just off by themselves, and they're not forming a line. So discrete is usually the most mode that the supercells, uh, that the supercells will form out of, and the supercells can create tornadoes and stuff. So most of the tornadoes come from discrete supercells. When it comes to that, so storm mode, MODE, storm mode. That's what you will hear from storm chasers. That's what you will hear from meteorologists. Is they'll say, "I wonder what the storm mode is going to be today." It all depends on what the storm mode is. That's what they'll say a lot. If you watch, uh, brother John McKinney. If you watch other storm chasers as well, those a lot of times they'll say it all depends on what the storm mode is for today, depending on what type of setup that sets up. So when it comes to that, and again, um, so storm mode. So yeah, linear or discrete. But discrete, usually when it's a discrete storm mode, that's when a lot of chaos happens. So that's when a lot of fireworks start to happen. Is with the discrete. So, but again, storm mode is what you hear. So, but great question there, Diesel. Keep asking, man. Keep asking away. Everybody, keep asking away. And um, y'all are awesome. Thank you to everybody on Twitch uh, who was watching. Thank you to everybody on YouTube uh, for being here. Thank you to everybody on Facebook, and thank you to everybody on Kick who is here. So, um, thank you so much for everybody who is currently joining in right now. It is 12:44 a.m. Central Time. It is 1:44 Eastern Time. It is 11:44 Mountain, and it is 10:44 Pacific Time. So thank you guys all for being here so much. You guys are all awesome. Um, Clearly, I wouldn't be in this position without all of you. Uh, and you guys, thank you guys for believing in me and trusting in me to provide you with trustworthy and accurate and detailed information when it comes to weather. Um, so it's very, very awesome that you guys put your trust in me to deliver that to you. So very, very, very thankful for you guys. Um, and I'm happy to help you, and I'm happy to teach you guys. I'm happy to give that knowledge to you guys. So it would be a disgrace to myself, and it would be a disgrace to you guys, and it would be a disgrace to the weather community if I did not teach back the things that I know, and that would be a disgrace to anybody else um, who who does not teach it back as well either. So a lot of times it's hard to find YouTube streamers channels that will actually teach you. And trust me, I know that. I have watched a lot of YouTube streamers that just will not teach you the things that they know, which I have found extremely extremely weird. Well, I shouldn't say weird, but I found the very off putting, and very it's like you should give back to your community, to this it's the people, especially to the people who are watching you. The people who are watching you is what keeps your channel going. So but yes, definitely, but I know what it is like to watch a YouTube stream or watch anything, and the whomever it is does not give back or teach back on on what they can be or could be. So that's why I am different in that. Um, I love communicating with the chat. I love chatting with all of you guys and answering questions and you know, whatever you guys have. And I will be 100% transparent with you guys and 100% raw with you guys that if I do not know, I'll say I do not know because I don't want to provide you with any false information or with any information that isn't correct. So I will straight up tell you, out of respect for you guys and out of respect for transparency, that I do not know the answer to that question, but I will help you find the answer to that question, and we will learn together when it comes to that. So but that's the way you got to be. Got to be transparent. You got to be forthcoming. Got to be forthright. Because again, I don't know everything, and I'm not going to claim that I know everything. So I would rather tell you. Of course, it's being, and obviously, it's being, for one, it's being honest. And just say I don't know the answer to that question. So, um, Libby says, John Boy, I think it is great you are building relationships with the chat as you build the channel. Yes, that's always my goal. My goal is to answer as many questions and to build relationships and partnerships with everybody in the chat. Now, are there going to be times that I miss questions? Yes, obviously, but don't think that it's you know, on purpose or whatever it may be. Just ask away and keep asking until I do see the question. But I will always do my best to answer every question that I can. Um, so, again, thank you so much, Libby. And Libby says, and that you are encouraging others who are building their channels. Yes, definitely. I'm brand new. I'm still brand new at this. I've only been on my channel for, um, let's see, a little over a month. You know, I've only been doing this for a little over a month. So I'm still new at the streaming thing. You know, I'm still new at, uh, you know, I'm a, you know, this is new to me as well. So, but again, it's a learning curve and it's a great learning curve. Um, so yeah, we all have to encourage each other to grow and build and, you know, where to go. So, Diesel Weather says, is there an altitude when looking at ecotops on the lower end that won't produce severe weather? I understand taller the greater chance, but below like 20,000 feet, can you still get severe weather? Yeah. Are you talking about like where severe weather might set up at in the thunderstorm? Is that what you're saying, Diesel? Hopefully I deciphered that correctly. Um, Let me know if I deciphered that correctly or not. So, yeah, because if you're talking about ecotops, right? I want to make sure. Um, okay, he said, yeah, Diesel Weather says yes. So basically, so in the gist of a thunderstorm, right? The higher the thunderstorm grows, the more atmosphere, the more potential, the more energy, the more again atmosphere it has to interact with. So that's why usually when a thunderstorm grows 55,000, 60,000 feet, whatever it may be, it has more of atmosphere to tap into. So that's why a lot of times thunderstorms that grow that large are really big thunderstorms. Uh, but thunderstorms can happen wherever the parameters are set up, wherever the ingredients come together for them to happen at. So you can still get severe weather in the mid levels. You know, the 20,000, 30,000 foot range. You can still get severe weather there. It all just depends on if the ingredients are correct for that thunderstorm to take place. So, but again, as they grow and what's looked at on ecotops and things like that, is again as the thunderstorm grows, it has more of the atmosphere to uh, to interact with. But severe weather can happen. Severe weather can happen wherever. Again, there's not really a. I mean, per se. there's not really a parameter that says, hey, a severe weather cannot happen below this certain, foot, or it can't be below this certain feet or whatever. As long as the conditions and the ingredients come together, that's all that it matters. That's all that it takes. So, so I wouldn't be fooled by, or I wouldn't be, misled by if someone says, "Oh, it can only happen at above this certain height, and it can't happen below this certain height," because severe weather can happen. Again, severe weather can happen where and whenever those ingredients come together in the atmosphere. So hopefully that answered your question. Equitops are just used a lot. Why people get so involved in equitops are just saying, oh, well, the thunderstorm has grown this big, it's grown this large, and it has more atmosphere to tap into, and that's usually where a lot of it just becomes bigger and it gets that more energized and everything. So that's just why people get more uh, in in love with equitops. But nonetheless, I did see another question here. Um, what is it, 60,000 or above for a tornado? No, it doesn't matter what the height. It doesn't have to be a certain height for a tornado. It can be, if that's what you're asking. The Hopefully I'm deciphering the question correctly, but the question, tornadoes don't have to happen if the thunderstorm is 60,000 feet, if it's 50,000 feet, if it's 45,000 feet, if it's whatever the foot is. That's the tornado is going to happen again if the ingredients and um, if the um, if the ingredients and if the parameters come together. So, yes, do they usually most happen more times than taller thunderstorms? Yes, or higher thunderstorms? Yes, but not always. That's not always the case. So again, so whether it's 60,000 feet again, whether it's 50,000 feet, whether it's 40,000 feet, wherever wherever it has a strong updraft, uh, things of that nature. So, but again, it just all depends, uh, but again, you will see them. Yes, you will see them mostly and mainly in taller thunderstorms, but it is not uncommon for them to happen in thunderstorms that are um, not quite that tall as well. So, but again, it's just like weather, right? It's just the weather. Like it's whatever um, it's whatever, it's whatever the parameters. It's whatever the ingredients come together, and um, so there's really no definitive answer on that. I mean, really, the only thing that's kind of there is no definitive answer. The only thing that you will see again most of is yes, they will be in taller thunderstorms. Tornadoes would be in taller thunderstorms, but again, that's not always the case. Um, there's cases of them being in shorter thunderstorms. It's just if you have a strong updraft, if you have a very tall updraft, if you have enough wind shear, if you have the shear, if you have the lift, if you have the instability, and you have the moisture, that's all that it's going to take. So whether that storm blossomed to 50,000 feet, um, whatever it blossomed to, that's all that it's going to take. So as long as as long as the parameters are in place, when it comes to that. But yes, equitops. But again, equitops. People again just love them. Again, people just love equitops because they just I don't know. They get. To me, it's I look at echo tops too sometimes, but I don't think that's really the some people you're like, oh, it's 55,000 foot echo top, it's 58,000 foot echo top, and then they kind of hone in on that, and then it doesn't even do anything. It's just a big downpour, or it's just a big hail, or something else. But a lot of people get too I've seen a lot. At least community that I dealt with, that I deal with and everything like that. I've seen a lot of chasers and a lot of meteorologists that get too much involved with ecotops. So uh, I mean, it's a good tool. Don't get me wrong. It's definitely a good tool. That's why it's there for. It's there to help. But I definitely would not use that as like the sure all be all thing of oh hey, this is going to produce a tornado or not. Definitely not that for sure. So, but some people love it more than others. So, but it is what it is. So um, when it comes to that. So um, some people just love it. So Libby says they can collapse rather quickly too, can't they? Yes, thunderstorms collapse all the time, and they collapse quickly. If you ever look at a radar sometimes, and you'll see a storm that blossomed up real quick, and it grew and it grew, and the next thing you know, on one of the next radar scans, it's already weakened, or whatever it may be. Yeah, so storms grow and grow all the time, and then once they and you'd be surprised, especially when there's boundaries, right? Like if storms grow close to boundaries, like depending on what side of that boundary they grow on, they can grow really, really, tall, whatever else like that. But then all of a sudden, now they moved over off into the other side of the boundary, which is just a couple miles down the road or whatever. Now all of a sudden, that storm is like completely gone because it doesn't have any fuel, it doesn't have any moisture, it doesn't have anything else. So yes. To answer your question, Libby, yes, they can collapse really, really quick, depending on certain boundaries and certain parameters and the ingredients that are around. Diesel says, "How do you read shear?" So wind shear, I see many. I see so many opens to click on in the apps. Hope not to no. How do you read shear? So wind shear. So right. So wind shear. We look at wind shear is. Um, Wind shear is the changing of winds as you go up in the atmosphere. So think about this. So think about if you have. Think if you were flying a kite, right, or something that's very light, right, and you can reach it up into the atmosphere. So, and when it let's say it hits like 3,000 feet, so the winds are going to come across and hit that kite at a certain direction, and it's going to push the kite off, let's say off to the east. Now, if the kite keeps floating up, and let's say to 6,000 feet, well, now the winds are going to hit it from a different direction, so now the kite's going to flip back and come back over. So, and then you're going to keep going up, and now it's going to hit it from a different direction. So now the kite's basically going to start circling, right? Now this kite's basically going to start rotating. So that's what wind shear is. You're basically, as you go up in height, you're changing wind directions, and that's what you need for rotation. So that's how you read that. And if you read that off of a map, I could show you how to read it on radar. I could show you like how it is measured, how they see that. But that is the definition of what wind shear is. Wind shear again is the changing of winds as you go up in height in the atmosphere. So that's what you need. You need uh, uh, winds blowing in one direction. I'm just using an example. 3,000 feet, 5,000 feet. They're blowing in a different direction, and they're different wind speed. So they take it and that creates rotation for that. So that is wind shear for you when it comes to that. Diesel says, I learned about CAPE, but shear is a bit questionable. Yeah, so that is wind shear. And again, I could show you on radar. I could show you how we measure that in the community, how we measure that in weather, what we look for, and again, what the parameters are. So and again, the method is if you were here the other night, remember the acronym SLIM for tornadoes to happen. So we need shear, we need wind shear, we need lift, we need instability, and we need moisture. So SLIM, we need SLIM in order for that to happen. So wind shear is very, very huge part in that because you need a changing of the winds. So that's one of the four main ingredients for a tornado. But yes, I could definitely show you sometime how to read that. If you're looking to get more like in-depth analysis on that. So yes, yeah, I could definitely show you that. I could definitely show you. Chasing for causes, you can tell if a storm passes by temperature and wind changes. Sure. If you're talking about like if a storm just passed you, or is that what you're referring to? Um, Saved by His Grace says, family, I forgot something. Prayer request. My mom isn't well. Oh, let me go back up. Where'd it go? Where did it go? Cotton Eye. Family, I forgot something. My prayer request. My mom isn't well, and I have a friend in Washington that needs prayers for encouragement. Been through a lot in her life, and she's lonely. Thank you all. Thank you, Saved by His Grace. Definitely will note that down to pray for, um, to pray for your mom and to pray for your friend as well. So, thank you, Saved by His Grace. Thank you for that. So, really appreciate that. So, yes, definitely prayers for your mom and for your friend. Definitely. So, um, yeah, definitely, 100%. Uh, that's what it's all about. That's the main overarching goal is obviously the to spread the gospel of Jesus. That's the number one thing. So definitely so. But yeah, definitely. Radar is a great thing too. Like radar is a great tool, and again, you don't have to be. And I taught a course on this. This was like my second or third video I did a live stream on. Um, Radar. You don't have to be a radar specialist or radar scientist um, to just kind of see what's going on there, especially if you're following it for like tornadoes or if you're seeing it for reflectivity and things of that nature. So, um, but besides that, I mean, um, definitely, definitely radar is definitely key to looking and understanding. Obviously, things are how things are transpiring, which way obviously way things are tracking. If things are, you know, things are calming down, if things are speeding up, things of that nature. So, but radar is a great tool. Obviously, it's not the 100% foolproof, but it is the best tool that we have. So, and there's different types of radar. There's reflectivity, there's velocity, there's correlation coefficient, there's echotops, there's water vapor, and I can just keep going on and on and on uh, about that stuff. So when it comes to that, so but yeah, it's very very awesome. There's so much in weather to learn about weather. There's so many, just so many topics. And again, um, it's just awesome stuff. And I'm so glad that you all are so inquisitive of weather, and that you guys are so passionate about it and learning, and again, trust me to provide you with accurate and you know trustworthy information. So I definitely appreciate that, to being a reliable source or a go-to source for you guys. I definitely appreciate that. So I do not take that for granted at all, because I am very, very thankful, very, very thankful for it. So it's a huge, huge, huge blessing from all you guys. So you guys are awesome. I mean, look, it's 106 my time, and there's still 12 of you concurrently in here. That says a lot. Um, because all you guys could be doing something else and spending your time somewhere else. But you choose to spend it, with me, and I appreciate that. So, um, I appreciate the family that's here. I think of you guys as a family. I think of you guys as, just not just supporters and just not uh, encouragers, but as a family. So I would treat you the same way if I seen you in person. I would. It would nothing would be any different. So. Um, Definitely appreciate that. I mean, you guys are so cool. So, um, you know, and uh, and to help you guys out, right? To push forward and help other streamers out, and to help other people in the weather community, and to help grow. Um, it's very awesome to help, and to help push that forward. So, yeah, I'm thankful for everybody who's in there. It's 107 here. It's 207 Eastern time. So. Um, it's 12:07 now Mountain Time, and it's 11:07 now um, Pacific Time. So when it comes to that, so but yeah, like I said, I'm very thankful for chasing forward cause. I'm thankful for Debbie, Omni, everybody who's in this. Everybody who is in here. Very thankful for all of you. Um, because you guys are awesome, like I said, and I say, and I'll continue to keep saying it. Thankful for everybody who's watching it, on Twitch, watching on Kick, watching on Facebook, things like that. So, um, Diesel says it's my weekend, so I love it up. Weekdays are 4 a.m. alarms. Oh yeah, those are brutal. Those 4 a.m. those 4 a.m.s are definitely brutal for sure. So, when it comes to that, definitely. Um, I have always been a night owl, basically myself too. There's just something about, I don't know. I think some people are always like, how are you stay up at like how are you like a night owl like that? And I'm like, it's I don't know. I think it's like ingrained in some of our heads, or some of our brains. Um, but yeah, I have basically been a night owl too. Um, for especially like in my adult, my adulthood and everything for sure. Um, but yeah, there's something about the night. I don't know. Maybe we're all vampires. I don't know. Uh, somebody W up vampires in the chat. I don't know. I'll get it started here. So let's get some W's for some vampires going on here. So definitely W to some vampires. So I don't know. Maybe that's what we are. Maybe I don't know. But uh, but yeah, definitely, yeah, definitely. That's my wife is like she's like the opposite. She's like the morning and stuff, and I'm like, I've never been a morning person. I just never have. So, but I mean, teach his own. Some people are a morning person. Uh, um, but um, yeah, some people are morning people. Some people aren't. So I've never really been a morning person. But if you are, that's cool. If not, it is what it is. So I've always, uh, as I call it, uh, like to wear my sunglasses at night. So when it comes to that, so um, yes, opposites do attract. Definitely, yes, yep. Um, yes, very thankful for her. Um, she's a huge blessing. Definitely. So um, wouldn't be here today, obviously without her help and everything, support either. So very thankful for my beautiful wife. Very thankful for her. Um, she's awesome. So, but yeah, definitely. Yeah, but again, to get back into that, I am definitely have never been a morning person. There's something about waking up to an alarm that I just really don't like, and I don't know. Maybe you guys like waking up to an alarm or like I just have never, I I just know I've just not really ever liked waking up to an alarm. But but again, the world works in the mornings, so of course going to work and everything else, even not being a morning person, um, I always had to force myself to be a morning person. So um, Diesel says I try to be both with 3 year olds. Oh yeah, definitely. I'm sure we have a 9 year old. Um, our son is 9, but I do remember he was 3, but we did not have twins. So you did say you have twins, so you got double the pleasure, double the fun, uh, as the saying would go there. So definitely have your hands full on that. Um, Definitely with two of them for sure. Um, my alarm and Libby says my alarm uh, and I tolerate each other. It annoys me and I smack it. Yeah, yeah. But I don't know. There's just something about it, an alarm that just I'm just like, what? This is just wild. So, uh, Sonia says I've never been a morning person, or if I hear an alarm go off in the afternoon, I went to hurl my phone in the nearest tornado. Just saying, yes, definitely, definitely, yeah. It's uh good thing, bad thing. They go to bed at 9 p.m. really well. Just never know when they're going to wake up. It's like a ticking time bomb. Yes, yep. I remember when our son was 3 years old, and definitely remember those days, man, for sure. But I'll tell you what, man, those days are great days, and it's uh, uh, they're just awesome, And I look back on pictures and stuff, and I'm just like, I just can't fathom just how fast that like they go from just the day they're born, and now our son is 9 years old. So it's just it is definitely enjoy it, man. Definitely enjoy it while you're in it for sure. So because it goes quick and it really does, and then you'd be thinking, oh man, you know, it just time gets away. So yeah, definitely Diesel. Yep, love it, and I love how cuddly they are because I know one day it won't be cool to cuddle dad. Yep, absolutely. Uh, yeah, both boys. Yeah, okay, nice. Identical twins or fraternal twins? Do you have there? Yeah, I agree with Libby. Definitely soak it in. Fraternal. Okay. Tizo says fraternal twins. Okay, nice. But I definitely agree with Libby. Definitely soak it in. And I know a lot of people always say they're like, oh, well, soak, like, but it really is true. It really is true. Like if you, um, I mean, I love our son, more than anything, and it's like I look back upon when he was younger, and I don't know where all the time is going. I'm just like, he's gone from being born to then 2 years old, to 4 years old, and 7, 9, and it's just like, and you can't get into that time back. You can't get none of that back, and it's just time does not stop. And so yes, definitely, you're definitely in the good old days. You know how they tell they say that was back in the good old days. You are definitely in the good old days right now, Diesel, for sure. So live it up the best that you can, because one day they're 3, and the next day they're 9, and then you're gonna wonder where 6 years went, and it goes by quick. Uh, and but yeah, seeing especially seeing our son, go through school, and just go through different grades and just different things, and you're definitely in the good old days for sure. Time speeds up the older I get. I remember high school days. Well, I stop and think that was 15 years ago. I know that all past generations meant. Yeah. Uh, Definitely. Uh, yeah. Yeah. Definitely. Um, it definitely flies. It definitely goes, and it definitely gets faster as you get older. It does. I remember when I was younger, and somebody said, I think I was like in my late teens or something, and somebody said, once you become an adult, um, it's like the years become longer or become shorter than the days. It's like the days become longer, but the years become shorter. And when had to think about that a lot, and now I think about it as I've gotten older, and it's like that's really true. Like the years are shorter than the days. That's what it seems like as you get older, and it's just weird, and it sucks at times, but it is what it is. So we just gotta make the best of it, enjoy it, and it's like, but yes, as you get older, the years become shorter than the days. Um, it's really wild, but it happens, and it feels like that. So, but yeah, man. But to have twins, that'd be awesome. My brother has twins, and those are they're awesome, man. My nephews, they're awesome. So, but twins would be pretty cool. So, definitely. But yeah, 3 years old, man, it's a great age. That's still that like like you said, cuddly, everything else, and but yeah, definitely cool stuff. So, Libby says I had a friend who had a PhD in statistics, and she said that they seem to go faster as we age because the time left is shorter than what has already been. Oh, I never heard that before, but I guess that would kind of make sense. So, um, wow, that is cool. But yeah, it really is. I mean, and I know people say the years just go by, and they do. They just freaking fly. I mean, look, this we're already almost 6.5 months completed of 2026 already. I remember when it was January, and it felt like that was just not that long ago. And it's like, whoa, what the heck's going on? So and then another 6 months from now is gonna fly by, and it's gonna be January of 2027. So it's like, what? It's just weird. It's just okay. But yeah, definitely got to live it up the best. Definitely got to. Um, Libby says I told her I'm not sure they are going faster if I'm going slower. Uh, Definitely so. Um, but yeah, definitely, man. Definitely the years just fly. Yeah. Um, but yeah, they do. They just yeah. The world keeps spinning, man. The time stops for nobody. Time is unbeaten. Time is undefeated. Can't beat it. You can try to slow the aging process, but I mean, they got like, I think they've been trying to work on pills and medicines and everything else. But I mean, at the end of the day, um, you're not going to be able to stop, you know, what God has, set forth, and everything. So you're just not going to be able to do it. So, um, so that's why we got to live our lives the best that we can and stay as healthy as possible, and obviously, and obviously, spread the gospel. Obviously um, the most and the best that we can, and just be thankful for what we have. So, Sonia says I'm 58 and time is going by faster each year. Yeah, I would understood definitely for sure. Debbie says, yeah, next school will be starting again, especially next month. Yes, yep, yep. And our son will be going into fourth grade, and it was like we were just in May, like he was just getting out of third grade, and now it's already July 12th technically. Well, it's July 12th Central Time now. So, um, but yeah, you know we're almost already halfway into July already. So, pretty wild stuff when it comes to that. So, Libby says. Libby said something here. Libby said exactly. It isn't about how long we are here. Stop it. It's stop it, chat, or whatever. My chat's being goofy as heck. What is going on? Where? Oh, exactly. Libby said exactly. It isn't about how long we are here. It is about how we use those years for Lord. Yes, absolutely. What you nailed it. That is exactly right. There's I couldn't have said it better myself. Diesel says, John, I plan on chasing and being safe next year. I want to hit the Effingham area. I feel like growing up, why does it seem like Effingham has so many tornadoes? It's just random. Yes, it is just random. Especially this year. This year, it is just random. There is no science behind it. It is just Evan this year again because of how the systems have set up this year and the way that the severe weather parameters have set up. Effingham just seems to have been kind of a center spot for that. So this year just seems like that. But come next year, Effingham or it could be 3 years in a row. Effingham gets absolutely nothing, So, and they don't even get. Maybe they get a couple of thunderstorms or something. So yeah, just very random, very random this year for Effingham. So, uh, Diesel says, I feel like growing up in the Terre Haute on the in Terre Haute on the news, they were always talking about Effingham. Uh, They might have maybe I don't know, but yeah, a lot of it is it's just chance. There's no like science behind that or any type of you know s- statistical data to point out um, just like a bullseye on Effingham, but um, again, it's just where the pattern where the system's going to set up. It's just like Oklahoma City, but Oklahoma City is definitely different because Oklahoma City is where it's located at and where uh, the systems eject out of the Rockies and where the moisture comes up from the Gulf of Mexico or from the Gulf of Mexico. So Oklahoma City. It would be a little bit of a different comparison just because of where that sits geographically. Effingham, although it's where it sits at here geographically in Illinois, is not the same. Does not have the same parameters set up usually as like in Oklahoma City or a Tulsa, Oklahoma, or like somewhere in Kansas and stuff like that. Uh, so yeah, just Effingham. I think it's just more of sheer just randomness, um, um, compared to like in Oklahoma City, which is set by a lot um, of the changing of the parameters, every spring and stuff like that. So Diesel says, weird question. Does the Mississippi River? Let's see what you said. Does the Mississippi River affect how storms approach us? Now, from a meteorological side, no. If there was perhaps a tornado on the ground and it was going to cross the Mississippi, possibly it could be affected by possibly the water it would be sucking up, by the atmospheric conditions based off of that water. So if a tornado's on the ground, possibly, but just a normal thunderstorm or whatever else, that Mississippi is not going to influence how that thunderstorm acts. But again, um, it's not acting as like a surface barrier. It's not acting as like a an atmospheric river. It's not acting as um, nothing like that. But again, if a tornado's on the ground, though, that's a different story. Again, because if it were to cross the Mississippi, and so let's say across the Mississippi at like its widest part or whatever it may be, it could either slow down the tornado or it could speed it up depending on the atmospheric conditions over the river there. So the main thing would just be if there's a tornado down on the ground. But besides that, it's not going to do um, anything out of the ordinary to any type of thunderstorm or any type of storm when it comes to that. So because if you ever see tornadoes hit rivers or hit lakes, they act very, very different once they hit that body of water. Um, Ami says many tornadoes have been reported crossing the Mississippi. Yes, yep, absolutely, um, absolutely. They will act different, but it doesn't mean that they will be stopped like completely. So, um, and it also depends on the size of the tornado. It depends on the forward speed of the tornado. There's a lot of parameters that go into place of that. So just as there have been a lot of tornadoes that have crossed the Mississippi, there have also been a lot of tornadoes that have dissipated over the Mississippi as well. So again, it just all depends on the parameters and it depends on the ingredients, the atmospheric conditions, and they're all different and they all no one storm is going to be the same hitting the atmospheric, different type of levels is going to be different. So things like that. Yeah. So, but yes, you are absolutely correct, Omni. Many tornadoes have been reported crossing the Mississippi. That is very, very true. Um, but yes, but if you ever do though watch, like again, if you ever watch tornadoes, uh, go over like a river or go over a lake, they will start to act differently given enough time in order to ingest more of that atmospheric condition that that lake or river provides. So, um, but a lot of times they will act that. So, Libby says we mentioned the Union City, Michigan tornado earlier, and that seemed to change how some people viewed water or ice-covered lakes' effect on tornadoes. Union City, yeah, that was from earlier this year, right? If I'm not mistaken, um, or was that like was it this year? Someone point me in the right direction. I think for some reason this year is standing out, um, but I could be wrong when it comes to that. So I could be wrong. Not 100% sure. So March 6th. Okay, March 6th. So that was in Union City, Michigan. So that would have been yeah, that would have. I'm trying to think about that one. I'm trying to remember that one. Um, I mean, it says it didn't fully go over the water. Okay. Libby says it took the ice off the lake as it crossed it. Okay. So the lake was still frozen? Oh, yeah. Okay. Well, I mean, I guess it kind of would be, right? I mean, it's only March 6th, so I mean, it's still cold, you know? So that would be wild to see a tornado go over um like a frozen lake or something. That would be wild to witness, for sure. Wow. I have to look into that some more. Then that's pretty wild. So that's very wild. But thank you again to folks on Twitch, folks on Kick, folks on YouTube, and the folks on Facebook. If you are new here, please like and please subscribe. Thank you for joining in for John Boy's Severe Weather Lab and Education. Appreciate that. Appreciate all of you guys who are all being here. So uh, definitely am appreciative. And again, if you would please like and please subscribe. Um, if you enjoy my content, and if not, I appreciate you being here as well, and I appreciate you checking it out. My content will not be for everybody, and I understand that, but I do hope that it is for you. So appreciate all of you for checking out John Boy's Severe Weather Lab. Appreciate that, and education. Appreciate that. Diesel says, "What made you fall in love with severe weather?" I think it's been a mixture of a lot of things, and I say that because there's something, and I can remember being super young, like 5, 6, 7 years old or something around there. I remember just always being in awe or more like very enthused and passionate about like tornadoes. And so I don't know if it's because I heard about it from a young age and maybe I heard stories or what it may be. uh, and or possibly have seen a funnel cloud or something. I don't know, but there was something that when I was younger that piqued uh, my yearning and my interest, and I've just have followed that ever since. And I've it's only peaked more as I've gotten older, and so I think it's been a lot of that, and just the sheer awe, inspiring power of God, that it's God's God's handiwork. But I think yeah, I just think that it's severe weather is just it's because it's never the same, right? It's always changing. Like no two tornadoes are the same, right? And you don't know if a storm is even going to produce a tornado. You don't know if that. I mean, you could have the most beautiful mezzo. It could have the most beautiful hook. It could have the most strongest updraft, and you just don't know if it's still going to produce a tornado or not. So I think that with me is just a lot of that, but it's also the sheer damage, the sheer power that tornadoes have and that severe weather has. And uh, I just find it fascinating, man. I find hurricanes fascinating. I find tornadoes fascinating. I find earthquakes fascinating. I find all that stuff fascinating. Like, it's just, to me, I don't know. It's just always been really cool to me. It's just always piqued my interest. Um, just wild stuff, man. Like, you could be sitting in your house, and the next thing your walls start shaking, and your everything's falling down, everything's falling over because you got an earthquake going on. Just a lot of just the pure, I guess raw beauty of it all. So that so. Sonia says, John Boy, I'm sorry, but I need to eat and get a little sleep. Yes, definitely, Sonia. Been a great stream. I held out as long as I could. Take care and God bless you. Thank you, Sonia. Appreciate you spending your Saturday with us. I appreciate that. Thank you for being here. Thank you for uh, uh, that. Thank you just for being a huge supporter, Sonia. Thank you for everything. So definitely appreciate it, Sonia. God bless you. Thank you so much. Diesel says, one thing I noticed that I love is nothing is ever the same. Yes, exactly, and that's one thing I love too. It's never the same. Like, you just, and you don't know. That's the beauty of it. That's like storm chasing. I mean, you don't know what that storm's going to do. You don't know anything of what's going to happen. You don't know, but that's why you have to chase it. That's why you have to go out there, in check, and that's why you have to go out there and do things, because you just never know. But it's always different. Never, no two storms are the same, right? No, um, none of that's, it's just all different. Um, and that's the beauty of it. You know, it's the beauty of why do some storms have a tremendous amount of lightning and some storms only have a little bit of lightning or maybe hardly any period, and things of that. So it's very very awesome, and it's very very cool, um, that when it comes to that. So yes, again, same thing with me. Same thing with me is thank you, Dominique, for subscribing. Thank you for being here. Thank you, Dominique. Definitely appreciate that as I make my way towards 3,000 subscribers. So, welcome in, Dominique. Thank you. Thank you very much. So blessed uh, to have all of you. Um, Oh, looks like Omni is taking off too. Thank you, Omni. Uh, Great chat. Thank you for joining. Thank you for support and encouragement. I appreciate that. So, very awesome stuff. Thank you, Omni, very much for being in here. Appreciate that. So, Diesel says I'm diving deep. I joined. Oh, nice. You joined the AMS. That's awesome. Joined the AMS. So looking forward to their meeting later this month for the Indiana chapter. Knowledge is wealth. It is. Knowledge is, well, that's great, because a lot of people like to say knowledge is power, which knowledge is power, but knowledge is actually more than power. Knowledge is wealth, definitely. So, um, yes, AMS. They have uh, so many good writings and journals and books and publications, and I mean it's just a wealth of awesome stuff from the AMS. So I mean, yes, you can deep dive. I mean, I highly suggest you deep dive as much as you can deep dive and learn that. And it's take classes from the AMS. Do it. Yeah, it's awesome stuff. AMS is a great organization. So, um, but yeah, so they're um, very great, very great certifying body, very great certifying organization. So, but awesome stuff. But yes, thank you, Omni, again. Uh, Great stuff, Omni. Great having you in the chat. Great having everybody in the chat here. So, um, you guys are all awesome. I mean, it's been a great chat. Learn about some clouds. Um, learn about just some great stuff there from clouds, and how clouds can help us uh, predict some of the weather that might be coming at us. So when it comes to that, but when it is, but yeah, clouds are cool. So when it comes to that, so yes, very thankful for, again, everybody who's on Twitch, everybody who is on Facebook, everybody who is on Kick, and everybody who is on YouTube. Thank you so much. Thank you guys so much for helping me, helping me in supporting my platform, and helping me grow my platform across different platforms. You guys are so amazing there. So very awesome stuff. And like I said, there are stuff in um I do want to check it out here. Um so I'm gonna be ending my stream here in about 19-20 minutes, being in about 2 o'clock. Uh sent you a message on Facebook on your page. It's some cool clouds that I saw. Clouds were awesome. Friday. What the? Why is my thing? Okay. Cloud. Go on. Oh, I saw clouds were awesome Friday night. I sent it. Ah, dude, my thing's jacked up right now. Let me get to it. Oh, Friday night. I sent it just because of the topic. Oh, nice. Very cool. Very cool stuff. Awesome, man. I appreciate that. Thank you. Yeah, and I got my. I have to check my bio, but I didn't know if my. I don't know if my email was on there now or yet. But I put my business email on there, but I don't know if it's on there. But I'll have to check after the stream. But besides that, I will be ending my stream in about 17 minutes. So at 2 o'clock my time, 3 o'clock Eastern. So that's going to be 1 Mountain, and that is going to be 12 Pacific. But before I end my stream, let's jump over to the NWS and see what they have for the outlook for today. And I say today as in Sunday, July 12th. So let's take a look at what they have set up. And it helps if I type on the right thing. Oh, get off there. There we go. All right, so let's see what they have here. So they have, that's the current outlook. So for today, got a slight risk over here in South Carolina and North Carolina. So marginal risk all throughout this corridor. Oh, we actually have a slight risk in Arizona. I do believe it is monsoon season, getting ready to start, which is, yes, it is going to be monsoon season. So sometimes you'll see some slight and some other, um, maybe enhanced, not very much, but possibly sometimes. Let's see what's driving it. There's a 2% tornado chance they have up way up in the UP of Michigan and way up in northern Wisconsin. So, very, very tiny, tiny, tiny part of the United States. They have a 2% up there. So, it's probably going to be driven by wind. Yep. So, the slight risk is driven by wind, and hail is up there in the north as well. So, that is for today. That is today's uh, what's driving that right now. Let's see what they have for tomorrow. Tomorrow, not much either. They got just a marginal down in South Carolina and Georgia, so not much is driving off of that. Um, let's see what they yeah nothing right now and for tornado wise. Just wind over there in South Carolina, Georgia, and hail is not really a hail threat either. Day 3, which that was updated yesterday. Mostly, yeah, that was updated yesterday. That has that's why it's still showing that for. So looks like pretty quiet. right now, but we are starting to get into July, the middle of July. So this is typically in typical weather fashion and typical weather season. This um, this is a month really where things start to turn almost like most mainly into wind driven events. Yes, there'll be some tornadoes, there can be, but the tornadoes really start to fall off significantly this month in July. So July and August tend to be more typically driven, wind event driven. So derechos, QLCSs, bow echoes, things of that nature. So a lot of that happens in July and August. It's just something that has to do with the heating of the air and the heating in the daytime, and the moisture being hot that just drives um, the wind driven events that when it comes to that. So, um, but again, Libby says that slow Sunday isn't a bad thing. It makes it less tempting to check the radar at church. Sure. Absolutely. Absolutely. Definitely. Definitely when it comes to that for sure. But yeah, definitely we definitely hitting again to July, and this is typically when uh let me show you on the map here. So if I show you on the map here, typically the jet stream rides up. Usually it'll start going up more north, and it'll start to kind of hunch back down or come back down a little bit. So that's why you'll see a lot in the summertime. You'll see a lot of the derechos and the QLCSs and the big wind events. They'll ride up this jet stream and they'll be up around this corridor here, be around this corridor here, because they're riding the jet stream, and the air is just so hot, um, and it's creating all that convection, and then you get the wind in behind it, and you get the wind pushing the storms in behind. So they're following the jet stream. So that's usually because usually a lot of times high pressure will build up down here, high pressure will build up down here, and then it'll ride what's called a ridge, and it'll ride that ridge up and over, and that's why a lot of derechos come in that direction like that up there. So that's because of the way the jet stream usually goes back up to the north a little bit there. It goes back, pushes back up to the north in July. So that's why a lot of times, if there is severe weather, a lot of times it'll be up in here in this region. Um, so especially if it's gonna be like tornadoes and stuff like that. But besides that, July and August are big time derecho months. So and big time QLCS months are quasi linear convection system. Um, so remember the saying: all QLCSs are MCSs, or mesoconvective systems. So remember, all QLCSs are MCSs. So if you were to say an MCS came through, that's technically that's perfectly fine if it was a QLCS. Uh, but remember, not all MCSs are QLCSs. But if it's a QLCS, it's an MCS. But if it's an MCS too, as well, because the mesoconvective system is huge and it consists of different things, it's not necessarily a QLCS. So a little bit confusing, I understand, but just remember, if it's a QLCS, it is also an MCS. So when it comes to that, Libby says that makes me wonder how many churches have a tornado plan in place and people in place to help people get to safety. That is a great. That's a great question. I wonder that too. because if you know that a lot of churches do get hit, unfortunately, and um, so I would hope and pray that churches do have some sort of safety plan, some sort of weather prepared plan. Um, but yeah, that would be, I don't know. I don't know the answer to that question because let's say you have even a medium sized church. Let's just say you got 200 people in there. You know, um, I mean, and if you have a basement, are you going to shove 200 people down in a basement, or are you going to go to like the most interior place? I don't know. You know, I don't know. That's a great question though. But yeah, because you definitely don't want to be like in like an exposed gymnasium or like in you definitely don't want to be in places like if your church does have like a gymnasium or something. If it's like uh, if it's like off to the side, if it's not like like in the middle of the church or whatever, but you definitely don't want to be there, near the outside wall. You obviously want to be in the interior side, but Libby says, I'm going to check with our head of safety guy tomorrow. That'd be cool. Or that's going to be cool, yeah. Diesel says, someone here in Indiana stole the batteries off of a tornado siren. I'm trying to comprehend out of everything that can steal in the world. Why that? Someone here in Indiana stole the batteries off of a tornado siren. You talking like the tornado siren that's like blasted throughout the city? Because I don't know how that's even possible. If that is why I don't know because that's connected to the EMS system. So um, like that's hardwired. As long as I know, as far as I know, it's hardwired. I don't. That's okay. Unless it's some sort of like different batteries I don't know about. But yeah, from what I know, that the tornado sirens are hardwired into the EMS system, into the county or whatever it is. So they're hardwired so they can um, send out the signal, and they so they don't. They always keep them powered out, powered up or whatever and stuff. So when it comes to that, so um, but yeah, so oh, Diesel said they said it wasn't working. Everybody, welcome in, Julie. Great to see you, Julie. Thank you so much. Uh, Appreciate you being here. Just about to end the stream here in about 5 minutes, but I definitely do appreciate you being here. You are a great supporter and a great encourager. Definitely appreciate that. So thank you so much. Diesel says my wife works for 911. Here she gets to flip the switch. Oh wow, that's pretty wild. That's pretty cool. Yeah, and I think that if I'm not mistaken, um, I'm gonna have to look that up, like, because I do know that, as far as I know, every like town or city or something has, there's supposed to be some sort of weather siren, tornado siren per. I think it's per. I don't know if it's a per amount of people or whatever it is, or um, I think some jurisdictions leave it up to the county or the city or whomever, um, but as far as I know, um, I still think there might be, or I still think there is some places that might not have tornado sirens, or that if they do, they're outdated and they might not work. Um, but I definitely don't know how people would not have, for people to not have tornado sirens in this today, in today's day and age, it's definitely uh, definitely not cool at all. That's definitely um, what do I want to say? It's like a disservice, you know. So, but I could be wrong. But I don't know if every town has tornado sirens. So when it comes to that, so but yeah, it's a I don't know. I've heard some pretty wild tornado sirens too. Some pretty scary ones too. Uh, yeah, forward it to me, brother, for sure. Yeah, definitely, man, definitely. So, but again, to recap here tonight. Tonight we learned about clouds, refresh on some clouds. Um, you know, we dove into a little bit of the science of it, the four main groups, the 10 different cloud types. Just that clouds are either made out of water vapor or ice particles. So when you look at a cloud, just know it's either made out of ice particle or it's made out of water vapor. So pretty cool. Um, but yeah, Libby says I imagine different states and municipalities have different standards and requirements. I would assume so too. I don't know if there's any federal regulations or not on weather sirens. I don't know if that state, like the state just says, hey, we'll put it down to a county level and you guys deal with it from there. I don't know. But all I know is that it would suck if there still are cities or towns or places that do not um, any type of siren for sure. So definitely. But nonetheless, so again, we learned about clouds, um, learned a lot about that. Talked to you guys about my rebranding. So, learned about, yeah, so rebranded my channel to John Boy Severe Weather Lab and Education. Um, so just very, very appreciative and just let you guys understand and know the rebranding. And again, more things coming in the pipeline. So it's a lot of cool things still coming when it comes to that. So very thankful, very blessed. So a lot of fun things still coming up. So definitely appreciative of all of you and everything else. So very very thankful. But again, yes. So clouds and rebranding, cool things coming down the pipeline for my channel. Um, so yeah, a lot of great stuff that is happening. So got a lot of so got yeah. So still again, this is just very thankful and blessed and to teach and to chat and to grow together from this. So and again, if you ever have anything to point out, or any questions, or any comments, or just anything you want to add, always feel free to add it. Um, yes, but I hope you all have a great Sunday today. I hope you all have a blessed day. I hope you guys all enjoyed the stream. I hope you guys all learned a little bit about something. Thank you guys for being great supporters. Thank you all for being in here. I know it's late. I know it's early, depending on how you look at it. I definitely appreciate that. Again, you guys are amazing. You guys are awesome. I wouldn't be in this position. One, if it wasn't, for God, and two, if it wasn't for all of you. You guys are awesome. And I would suggest if you can watch brother Pastor John McKinney preach um, today. On Facebook, his church does live stream his teachings. So I would definitely check them out on Facebook, and give Brother John a view on there. But yeah, so thanks again for a great stream. Thanks again for the great questions. Thank you, Libby, for great modding. Thank you to all the moderators. Thank you, Debbie. Thank you, Sonia. Thank you to everybody who was in here uh, today. And if I missed anybody, thank you guys so much. Again, thank you to everybody on Twitch. Thank you to everybody on YouTube. Thank you to everybody on Facebook. And thank you to everybody on Kick. You guys are awesome. I do plan on live streaming today. Today, I will say today because today is Sunday. So I hope to see you all back again today for a great stream, for great fireside chats, for great learning about weather, and just making a lot of great memories along the way. You guys are all awesome. Please like, please subscribe, please share. Definitely appreciate it. And again, yes, thank you guys for being here. Thank you guys for joining in. You guys are awesome. So, but yes, thank you guys. Have a great Sunday. Look forward to hopefully seeing you guys later today, and enjoy wherever you guys are at. Enjoy it, and make the best of it and make the most of it. So thankful for all of you. Again, you guys are all like family. So very thankful, very blessed for all of you. So, and like always, be brave and let the Lord